Linux isn't just a thing to brag about to potential romantic partners. Linux skills, and more broadly speaking, the ability to use the command line, the shell, the terminal, is going to be useful in any software engineering job and even any DevOps, IT, or automation job. And if you're working anywhere close to the internet, understanding Linux is going to be something that's invaluable to your toolset. So in this video, I'm going to walk you through our entire Intro to Linux course on boot.dev. But up front, I want to explain to you exactly what this course is and what it's not. I'm calling it Learn Linux just because that's what most people think of and associate the terminal with. When they think of ls, cd, grep, find, they think of Linux. But to be honest, the name of the course is a bit of a misnomer. It should probably really be called Learn How to Use Shells and Terminals in a Unix-like Environment.
It's a Unix system. I know this.
So we'll be focused on shells and terminals in this course. And you can use Linux or Mac, which are both Unix-like. Navigating the command line on those operating systems feels pretty similar. If you are on Windows, don't worry, we're gonna set you up with a WSL or Windows Subsystem for Linux environment so that you can follow along in Ubuntu. The chapters in this course are terminals and shells, file systems, permissions, programs, input/output, and package managers. The goal of this course is that when you're done, you're gonna feel very comfortable using the terminal to do your daily work, both on Linux or on Mac. And if you're in a job where you work with remote servers, for example, remote web Linux servers, you're gonna feel really comfortable navigating around the file systems on that kind of a server. That said, this is not a course on the Linux kernel, or on the operating system, or on server administration. This course is really a prerequisite to those types of courses. This Linux course is course number 2 on the backend developer roadmap on boot.dev, for a reason. And that's because all of the shells and terminal skills you're gonna pick up in this course are something that not only every backend developer should have, but I really believe every developer in general should understand how to navigate the command line. Now, by the way, just so you know who's teaching you this thing, I'm Lane. I'm the creator of boot.dev, which is an interactive platform for software engineering education. I've been writing code for about 15 years now, and professionally for about 8. I've mostly specialized in backend and data engineering, but like most developers, I've dabbled all across the stack. Now let's talk about how you're actually going to complete this course. Option 1 is to go grab a bag of popcorn, sit back and watch as I do all the work for you. You can pretend you're learning as I type everything out. That's not a good option. If you watch this entire course without pausing, you've done it wrong. So make sure that you're at a computer, that you have access to a terminal, and actually follow along as we go through this entire course. Now, the content of this course, just like all courses on boot.dev, is totally free. I highly recommend going over to boot.dev, making a free account, and following along with all the text instructions as you watch this video. Now, what makes this free content model work is that all of the interactivity on boot.dev, after a certain point, is paid. So if you like all of the gamification features, if you like the solution peeking, the AI assistant, the certificates, all that stuff, that is available with a paid membership, but you don't need the paid membership to take this course. But if you do want to become a member, I've got a coupon code for you. You can use code BOOTS for 25% off your first year if you choose an annual plan. Now, enough with the shilling, let's talk about what happens if you get stuck during this course. Please don't ask for help in the YouTube comments. I can't reasonably help you there. Head over to the boot.dev Discord, totally free to join. Feel free to ask questions in there. Now, let's talk about shells, terminals, and Linux. All right, so I'm here on the Learn Linux course / Learn Shells and Terminals course on boot.dev, and let's jump into it. So just to give you kind of a lay of the land, I've got my terminal emulator here on the right. This is Ghosty. And then I've got the lesson instructions on the left-hand side of the screen. And this first lesson, I'm gonna kind of skip this first part because we already went over that in the introduction to this video. So let's just jump straight into the assignment. All right, so find and open a terminal on your computer. I've opened Ghosty, I'm on Mac OS. If you're on Mac, you could use Ghosty, you could use the built-in terminal. If you're on Windows, you can open the command prompt. And if you're on Linux, hopefully you know where your terminal is. So we're just gonna grab this, paste it into our terminal and run it. And echo hello world. It just prints back hello world to the console. And then it says, once we've done that, just answer the question. So hop over to the question. What happened when you pressed enter? The text hello world was printed to the terminal console. Pretty straightforward. If you're coming from the world of Python, it's a lot like print hello world, or in Go, fmt.println hello world. This is the terminal or the shell's equivalent of print hello world. The words terminal, shell, command line, CLI, and command prompt are often just thrown around haphazardly by programmers. And even though the precise definitions vary slightly, we're usually talking about a program that lets you interact with your machine through text. If you're new to the command line, you're already probably familiar with GUIs, or graphical user interfaces. And a GUI is just a fancy visual interface that lets you get stuff done on your computer. Think of a Windows desktop, for example. It has menus to sift through, icons to click on, and even complex window management systems. A CLI, or command line interface, is a much simpler alternative. Instead of using complex visual buttons and menus, you interact solely through text. Want to run a program? Don't click on an icon, just type the name of the program. Want to view a file? Don't open Microsoft Word, just type a command. Now, while GUIs do have a lower barrier to entry, that is, they're often self-explanatory to use, they're also pretty limited. A command line interface is more powerful because you're not limited to the buttons and widgets that are provided by application developers. Instead, you get direct access to the lower levels of your system. As a programmer, it's non-negotiable. You need to be comfortable on a command line. All right, next lesson, command line versus GUI, or graphical user interface. So in all the other courses on boot dev, or I should say kind of the beginner courses, you'll be coding mostly in your browser. And when you want to run your code, you'd be clicking a run button. But typically as a real developer, and that's not entirely true, this is, this skews toward my experience as a web developer, but it's very often the case that you'll be running your programs from the command line rather than by clicking a run button. Of course, there are exceptions to this. There are IDEs out there where you do click a run button, and those developers aren't any less professional than those of us who use the command line. But it is very good to become familiar with the command line because you will be using it. For example, when I'm writing Python code, I'm typically running my code by typing Python main.py into the terminal rather than clicking a run button in my editor. That's just the way I like to write my code, or I should say to set up my development environment. So what is a CLI? Well, it stands for command line interface, but it's a text interface for interacting with applications and programs. So if you're coming, not from a developer background, you're probably used to interacting with your computer through graphical user interfaces. You're clicking around on different icons, you navigate folder structures using something like Windows Explorer or Finder on Mac, and you're using your mouse a lot. You're using your mouse, you're looking at images, you're clicking on things. That's what a graphical user interface is. A command line interface is text only, which, basically that means it's going to be harder to learn because you have to learn all of the different commands. But once you know the commands, it's actually a lot faster to use a command line interface typically because it is all text. And so you can go as fast as you can type. It also makes automating things a lot easier because it's a lot easier to write a program that works with text than a program that, tries to spoof mouse clicks and things like that. So onto the assignment for this one. It says, in your terminal, run the following command. Who am I? Who am I? I get Wags Lane. That's, again, I'm on Mac. That's the name of my logged in user account. And when we're done, we answer the question, what happened when you ran the command? My username was printed to the console. All right, the next lesson is on installing Windows subsystem for Linux. Now, I'm gonna skip this section because I'm not on Windows. If you're on Windows, you will not be able to use just the default command prompt for the rest of the course. You'll be using Linux running on your Windows machine with WSL. So if you are on Windows and you need to set up WSL, please come to this lesson. It's lesson 3 in chapter 1, and all the instructions are here. This is very battle tested. We've had thousands of students install WSL and use it. Don't worry, it won't bork your Windows installation. It's not a entirely separate dual boot situation where you have to partition your disk. It's nothing crazy like that. It's really genuinely pretty simple to set up. That's why we recommend it. So if you're on Windows and you need to get WSL set up, come set this up. Once you're done with this, you will have a Linux terminal, a Linux shell that you can use. It'll be Ubuntu, it'll be Bash, and you'll be able to follow along with the rest of the course. For the rest of the course, everything we do will work with Bash and ZSH as the two shells on Linux and Mac. and there really won't be much customization that needs to happen. Both Linux and Mac are Unix-like systems, and all the stuff we're going to cover in here is similar enough that it will work. So we'll go ahead and skip that one. All right, so what is a terminal? Now, as developers, sometimes we use all these terms interchangeably. And what terms are they? Terminals, shells, command line interfaces. You'll often hear developers use those as different words to just refer to the same thing, which basically means I'm typing text into my terminal. And so just understand that we often mean the same thing and we kind of get sloppy with words, but they do actually have different definitions. So a terminal, to get super pedantic, actually doesn't really exist on your computer at all. A terminal is a physical device, like this big old image here. So way back in the day, you had to have like a terminal. You could basically think of it as like a monitor keyboard combo, and it's what allowed you to interact with software. It's like a physical terminal. These days, we don't use those very often. We use terminal emulators. So that's what Ghosty is. It's a program on my computer that emulates a terminal. It allows me to type text in and it renders text out back to me. So to get very pedantic, a terminal is just that. It's a place where you can type in text and a place that can render the text back. So let's answer the question. A terminal or terminal emulator is a text-based operating system, a set of commands that can be used to control a computer, a program that accepts text-based commands and can render text on the screen, or is a freshly baked Raspberry Pi. It is a program that accepts text-based commands and can render text on the screen. Okay, so if that's what a terminal is, then I mean, I don't want to offend anyone who works on terminals because, and to be clear, they're not simple programs necessarily. But when you compare it to the shell, the terminal can be thought of as kind of dumb. Like it doesn't actually have to interpret commands. All it has to do is accept text and render text. So the shell is the program that actually provides the interactivity in the terminal. It waits for the prompt, it processes the prompt, it interprets the prompt, it executes the prompt, and then it gives you a new prompt when it's done processing the old prompt. The acronym for this is REPL, read, evaluate, print, loop. So when we type a command like echo, hello world, when I hit enter, the very first thing the shell does, because the terminal is sending that command to the shell reads that, echo hello world, it evaluates it, what should I do with this prompt? It prints a response, in this case, hello world, and then it loops and gives me a new prompt, which is why I'm able to do it again. So in your own shell, run the following command. Let's go ahead and run this. Looks like it's adding up some numbers. Paste the output of that command into the text box. All right, let's hop over to the text box. Paste that in. And this is really just to show another example of a prompt that our shell can evaluate, right? So in this case, we're saying expression 1, 2, 3, 4, 5, 6 plus 7, 8, 9, 0. It actually does that addition. Shells like Bash, or in my case, ZSH, they're sophisticated programming languages and they can do a lot of things. So it's not just that they can echo hello world back to you, they can also do math. So like we said in the last lesson, these shells, ZSH and Bash, they're REPLs, but they're also kind of fully fledged programming languages. They're built to be fairly simple scripting languages, so they're not always best for building larger web applications. Shout out Sarah and Bash Stack, making it possible, although maybe not recommended. But the point is you can do very sophisticated things in Bash and ZSH and just kind of shell scripting in general. And so like most programming languages, you can use and create variables. In Bash and ZSH, creating a variable is very simple. So for example, here I can create the variable name, set it equal to my name, Lane. And if I want to use the variable, this is where it gets a little different from a language like Python. Instead of just using the variable name again, I actually have to prefix it with this $sign. So anytime you set a variable, you don't need the $sign, but when you use it, you do. We can echo that back out. You can see it interpolated the string Lane back into the name variable. So for the assignment, for the rest of this course, you'll be a forensic developer hired by the fictional World Bank to investigate a security breach. And like most mega corporations, they don't know what they're doing. But they're happy to overpay you to come in so they can say a third-party expert has reviewed their systems. As it turns out, you're not an expert yet. we're going to learn in this course. But you are happy to learn on someone else's dime, so why don't we jump right into it? Anyhow, you'll be using your terminal and shell to traverse files, manipulate text, run programs, right? This is all the stuff that we'll be learning throughout the course, but we'll do it within the kind of story-based context of this World Bank megacorporation. We're going to be a forensic developer, looking around through files, grepping through stuff, finding stuff, printing it out, and doing just kind of general analysis on text as a way to kind of practically learn how to navigate a Unix-like system. And I didn't really cover this in depth, but like the course is called Learn Linux, and a lot of you will be on Linux, but Mac, from a text-based perspective, like on the command line, is very similar to Linux. We call it's Unix-like. And so all this stuff kind of just works out of the box. Server administration is like a whole nother can of worms. Like it's not like a Linux server and a Mac server created equally. And also to say local development isn't exactly the same either. But the point is a local development and kind of navigating your shell and terminal on Mac is very similar to Linux, whereas Windows is not. That's why if you're on Windows, we have you use a Linux virtual machine, specifically WSL. Okay, so for the first part of the assignment, set the following 3 variables in your shell. So first we're going to set bank name equal to World Bank, founded equal to 1969, and the CEO is the famous Jeff Gates. Next, we're going to write and execute a command that will print the following using echo and the dynamic variables that we just set. So we're going to echo the string. Now we have a variable for World Bank, so I'm going to go $, world, or sorry, $, bank name, was founded in, I think we go $, founded, interpolate that variable in, and then by $, CEO. Run that, see if it worked. World Bank was founded in 1969 by Jeff Gates. Perfect. All right, paste the entire command that generated the correct output into the text field. Let's do that. And we're good. Okay, history. When you're working in a REPL, it's really helpful to be able to see the commands that you've typed in the past. Now, to be fair, like we're looking here at my terminal, we can see everything that we've typed in the past, but there actually is a command that makes it easy to look at everything we've typed in the past. So it kind of keeps a log of it, and that's the history command. So it looks like this, history. And you can see here's the last, 15 commands that I ran. So in your shell, set 2 variables, department to engineering. So department equals engineering. And then team equals ops. Use echo to print the following message. Oops. Using the department and team variables. So we're going to echo. I work in $department on $team. Run the history command and paste its output into the text field. Okay. And we're good to go. Now, as you can see, my terminal is getting a little cramped here. I'm all the way down at the bottom of my screen. So the course covers it later, but I'm just gonna go ahead and do it now. I'm gonna type clear, and it just clears up the terminal. It doesn't erase my history, but it does give me a nice clean window to work with. Okay, so you'll often want to rerun a command. You could just type it again, but assuming you don't have the words per minute of the Primeagen, that can be a pain, and I do not. My words per minute is a lowly like 80, even worse when I'm on camera. So I don't like retyping commands. So instead of typing history again, I can just hit the up arrow key and look at my last command. I can also keep typing up, and you'll see it's just cycling through all the stuff we ran in the past, and the down arrow key goes kind of back, forwards in time, back to the future. So for example, if I go echo 1, echo 2, echo 3, hit up arrow once, it goes to echo 3, up again to echo 2, up again to echo 1, and I can go back down to 2, back down to 3, and back down to an empty prompt. Okay, and then, now we're gonna cover the clear command. So there we go. And we'll answer the question. The blank arrow goes back in your history, and the blank arrow goes forward. Up goes back, and down goes forward. Another question. The clear command opens a new terminal window, deletes your shell history from memory, or clears the terminal screen. It just clears the screen. All All right, terminal alternatives. So like I said, I'm on Ghosty. It's a brand new terminal emulator made by Mitchell Hashimoto, the founder of HashiCorp. It's pretty awesome. This is like a brand new terminal emulator. It just came out. Aside from Ghosty, I know a lot of people use Alacrity. Alacrity? I think that's the most common one. Currently, my daily driver for text editing is Zed, which actually uses Alacrity onto the hood, I'm pretty sure. But I just used the integrated terminal for the most part. There's also integrated terminals built into things like VS Code and Cursor, if those are your editors. Pretty much every editor or IDE does have an integrated terminal, though a lot of people don't use the integrated terminals. And then if you use something kind of more command line native like Vim, it's much more likely that you're going to use something like Ghosty as like full screen terminal emulator because your text editor Vim or NeoVim runs in the terminal. So all this to say, pick the terminal emulator that you want to use. For this course, it doesn't matter. You can just use the default terminal if you want. Check out this lesson and check out these other terminal emulators if you're curious. All right, the question, which is not a terminal emulator. Windows terminal, Ubuntu, Ghosty, or Alacrity. Ubuntu. It's an operating system, not a terminal emulator. All right, on to chapter 2. What is a file system? Now, you're probably already familiar with the idea of a file system. If you've been using a computer for most of your life, the idea of folders or directories, as they're called in Unix-like systems, kind of nested within each other in a hierarchy, probably already really familiar with this idea. So that's, at its essence, that's what a file system is. It's this tree of directories, starting at a root directory, which contains other directories, and then kind of go as deep as you want. That's not entirely true. We don't have infinite space on computers, but they can go pretty deep. And directories just contain other directories and other files. So directories are just containers that hold other files. And then files, of course, really they're just binary blobs at the end of the day with some metadata attached to them to tell you, what's in that binary blob of data. A file can store anything. It can be an image, text file, PDF, code. It really could be whatever. And it's up to whoever's reading that file to interpret that data and use it as intended. So when you open your terminal, the working directory or the directory that you're in is going to be somewhere. Most likely it's going to be in your home directory. So for example, if I run this pwd command, it shows me that I'm in /users/wagslane. So / represents the very root directory. If I scroll back up here, you can see this very first directory. That's just /. Users is then like another directory down. If I list the root directory, you can see I have all these other directories in my root, but we're specifically in users. So, and then within users, we're in my username specifically. So /users/wagslane. All right, you've remotely logged into a suspicious employee's machine at WorldBank. First, you need to determine where on their file system you are. So we type pwd, paste the full output of the command into the text field and submit it. So we'll just grab, I'll just do it again, and we'll just grab that /users/wagslane. pwd is print working directory, shows us where we are. Paste that in and cross our fingers, we got it right. When you're working with the command line, file paths are the bread and butter of navigation. You're probably already used to thinking of files and directories as nested tree structures. After all, that is what they are, and that's how Windows Explorer or Finder on Mac display them. A file path is just a text-based representation of one file or directory in the hierarchy. All absolute file paths start at the root of the file system, which is just the very top directory in the hierarchy. From there, everything is nested inside a tree of directories, with each directory in the file path separated by a /. Now, if the path you're looking at points to a file, then the last section of the file path will just be the name of the file. But if you're looking at a path to a directory, then the last section will be the name of the directory. To give an example, in this hierarchy, the path to homework.txt is /documents/school/homework.txt. And the path to the work directory is just /documents/work. Okay, file paths. So the output of pwd, or print working directory, is a file path. And a file path is just a string that represents where we are on a system. So again, if you're used to graphical user interfaces like Windows Explorer or Finder, you might be used to kind of visually seeing the tree of files. A file path is just a text representation of exactly where we are. Now, of course, file paths can be annoying to type when they're super long, But when you're working within the context of a program, using file paths to refer to different files on the file system is much less error prone and much more convenient because it's all text-based. So let's break this down. /user/lane, the first slash represents the root directory. We kind of went over this. Inside the root directory, we have a users directory. And then in that directory, we have a wags lane directory. So we're really 2 levels down from the root. Jumping into the assignment says time to start digging for evidence. If you're on Windows again, make sure that you've switched to a WSL Ubuntu terminal so that this will actually work. All right, first step is we're gonna download this World Bank folder. It's being downloaded from the boot dev GitHub, and we're gonna unpack it into our current directory. So we're in our home directory. I'm gonna copy this, paste it in, run it. I'm gonna type in my password. And now I should have a World Bank directory. So if I run ls, you can see everything that's in my, let me clear this up. Clear ls. This is all the stuff that's in my home directory. And now you can see there is a World Bank directory there as well. So we're going to change directory into World Bank, which is the cd command. Now, here's just a little trick. I think we cover it later in the course, but you're gonna see me doing it and wondering what I'm doing. If I start typing the name of a directory in the current path, and then I hit tab, it'll autocomplete. So the only directory in my current directory that starts with WORL is World Bank. So I hit tab, it autocompletes. I can change directory into World Bank. I also could type it all the way out. Nothing wrong with that either. This won't work because I'm already in World Bank, but you see how that works. And now you can see my prompt's a little different. Notice that my shell is showing me that I'm in the World Bank directory now, whereas before I was in the home directory. Okay, now within World Bank, use the ls command again to see the contents of the World Bank directory. So ls for list, and we can see 4 different things. Paste the console output into the text field and submit your answer. Okay, so we just copy and paste. By the way, I'm gonna fix this after I record this video. I don't think that go.mod should be there. It's not gonna break us submitting the assignment, but if you're doing this later and it's gone, it's because it wasn't supposed to be there and I removed it. So don't be alarmed if the go.mod is no longer there. All right, moving on. Parent directories. The cd command changes directory to move into a directory. We went over that. But how do you get back out, right? So we changed from our home directory into World Bank. Now we want to get back out. We can do cd ... So ... is basically a special alias for going back up a directory, one single directory level. Okay, so navigate back out of the World Bank directory. We just did that so that you're in its parent directory, which in our case is our home directory. Then run the ls command again, but pass in the name of the World Bank directory as an argument. So if I just type ls from here, because I'm in my home directory, I see everything that's in my home directory. If I want to see what's in World Bank, I could cd into World Bank and then run ls, which by default prints the current directory, or I can pass in an argument to ls and say, no, you know what? I want to specifically list the contents of World Bank. And then we just copy and paste this again. Moving on, absolute versus relative file paths. So far we've been mostly dealing with relative file paths. They're file paths that are relative to where we currently are. So my current working directory is /users/wagslane. World Bank, like ls World Bank, that's a relative path because I'm saying I want to list the contents of the World Bank directory. You can find it relative to where I am currently. /users/wagslane is an absolute file path because it's giving us the full path from the root. So the difference is absolute file paths will work no matter where you are on the system because they can always be traced back to the root. They can kind of start from there and then go forward. A relative file path depends on where you are. It's kind of like you can always give someone your address to your house, and it doesn't matter where they live, they'll be able to find your address because your address is absolute, right? You can tell Amazon your address, they can ship a package to you. When you're out walking with your friend, to give them directions to your house, you can say, oh, my house is up 2 streets and around the corner. That's a relative direction. It depends on where you and your friend are standing at the moment. It's a great way to give directions, but you can't tell Amazon, oh, my house is up 2 streets and around the corner. It doesn't work like that. Okay, so all of this just basically explains that. So the tell is that an absolute file path always starts with a slash because it has to start from the root, whereas a relative file path will not start with a slash, and it will kind of go from where you're at currently. Let me show you what I mean. So I could do cd /users/wagslane/worldbank. That'll work. That's an absolute path. If from here, I try to get into the worldbank directory, cd worldbank, it won't work because there's not a worldbank directory inside of the worldbank directory where we are. But if I go up a level, now, because there's a worldbank directory here, I can use a relative path to get back into it. Cool. All right, so which one should you use? Well, it depends. Generally, when you're just like working in your terminal like this, you have a working directory. You're gonna do stuff. Let me clear this up. You're gonna do stuff relatively. You're gonna list some files. You're gonna cd into private. You're gonna work in a relative way. Absolute paths are much more useful when you're doing like system-wide stuff and you need to know exactly where stuff is on your system, or when you're like installing programs, you need to know where that program installed on your system so that when you need to run it, you know where to find it. When you want to remove it, you know where to find it. And let's answer the question, which is a relative path? Well, it's the only one that doesn't start with a slash. All right, another question, which path will refer to the same file regardless of the current working directory? That would be an absolute path. Again, the only one that starts with a slash. There we go. Files. Okay, you're probably familiar with the concept of files from using a GUI like Windows Explorer Finder. And at their core, files really are just blobs of data. It's tempting to think of files as something more, like a lot more specific than that. File types and file metadata, and like that stuff exists, but it's important to understand that like when you peel back all those layers, a file really is just kind of a blob of bytes that your file system keeps track of. It keeps track of its location so that you can go find it using a file path. So the cat command is used to view contents of a file. Really weird, right? Cat, what? It's because cat is short for concatenate, which again, what does concatenate have to do with printing stuff? Well, it's called concatenate because you can like print the contents of two files and smush them together. Concatenate means to put things together. When you concatenate two strings, you sort of add them end to end. And so for that reason, it's called cat. It's really weird. Most of the time, in my experience, you're catting a single file, which makes the name a misnomer because you're not really You could argue you're concatenating the file to like standard out or something. Whatever. Point is, you use cat to print the contents of a file or multiple files. That's like bottom text, what we're doing here. Okay, so use the cd command to confirm you're in the right place. We want to be in the worldbank directory. All right, let me go back up to worldbank. Use ls to confirm that you're in the right place. I am. You should see a public directory. Cd into that. Let's go into public. You should see a file called prideas.txt. Let's take a look. There it is, prideas.txt. Use the cat command to view its context. Cat prideas.txt. Lots of text in that file. Cool. It's a plain text file. Paste the context of that file from your terminal into the text field and submit it. Very good. Earning all sorts of awards. Next one. All right, head and tail. Now, sometimes you don't want to print everything in a file. Files can get really big. This is very true. Worked on a lot of servers. Servers like to keep log files, and log files can get really, really, really big. So catting the log file, your terminal might not be able to render all the text fast enough. You can just sit there rendering text, waiting, terminal scrolls. It's unfortunate. So that's where the head and tail command come in. The head command prints the first n lines of the file where n is a number you specify. And if you don't specify a number, it'll default to 10. So, and then the tail command does the last n number of lines of the file. Okay, time to start investigating the main transactions. So cd into worldbank private transactions. So let's go back up. We're going into private transactions. Run the cat command to view the contents of 2023.csv. So cat 2023.csv. As you can see, there's a lot of stuff in here, like a lot of stuff. Really annoying to deal with that many lines of text. Use the head command to print the first 6 lines. So we'll do head-n6 and 2023.csv. Now we get a nice 6 lines. In fact, let me clear and do that again. There you go. Those are the first 6 lines. Looks like we're doing 6 lines because the first line of the file is the header. See, these are columns in a CSV. A CSV is like a text-only representation of like an Excel spreadsheet, basically, or like a Google Sheets document. All right, then use the tail command to print the last 5 lines. Okay, tail-n 5 2023.csv. All right, submit the combined first 6 and last 5 lines for a total of 11 lines. All right, let's do that and that. And there we go. More and less. The more and less commands let you view the contents of a file, one page or line at a time. As the adage goes, less is more. And it's kind of funny because in this case, like less literally is more in the sense that like the less command is kind of just the more advanced version of the more command, which was kind of a tongue-in-cheek naming thing. But basically, the only reason to use the more command is if you don't have access to the less command. And it's very likely that you do have access to the less command. It's not like it's, you know, come out in the last 3 years or something. So less is the only one that we're going to worry about. Okay, the assignment says you found nothing suspicious in the first and last transactions of 2023, but we are not done yet. It's time to dig through the middle of the file as well. Run less and pass in the path of 2023.csv. All right, less. In fact, let me clear. Less 2023.csv. Notice that you're now in an interactive mode and you've lost your shell prompt. This is true. If I hit enter, it just moves me down the file. And that's because less has taken over your terminal window. This is how a lot of terminal-based text editors like Vim or NeoVim work. It's, you know, you run NeoVim and you get into this sort of interactive mode in your terminal. You lose your prompt while you're in the program. Okay, press enter a few times to scroll down. Cool, just to see how that works. Press Q to exit the less program. By the way, that's true of a lot of terminal programs where you press Q to quit. Not true of Vim. That's why leaving Vim is really hard. So press Q, rerun the less command, but this time pass in the -n flag to show line numbers. All right, less -N 2023.csv. Cool, now you can see we got line numbers over here on the right-hand side. Kind of convenient. You can use the spacebar to scroll down a page at a time, and you can go back up by pressing B. Okay, cool. So if we want to go whole pages at a time, that's really nice. Can move a lot faster. All right, find line 153. It's right there. Oh, that's so awkward. It's right there at the end of my page. I can use space though. Oh, back, space. Damn it. I want it in the middle of my screen. Whatever. It's right here. It's fine. It's good enough. Copy and paste the contents of that line into the text field and submit it. All right. Moving on. Touch. The touch command updates the access and modification timestamps of a file. It's like touch update. By default, if the specified file does not exist, touch will create an empty file with the given file name. Because of this side effect, you'll often see this command used to quickly create new files. So again, this is one of those things where it's like, you know, it's the command is named something, but it's often used for something that's like, there was probably a better name for that, like cat. You know, like maybe print would have made more sense than cat, but like there is a valid reason for the naming, but it's just like not always what you use it for. Touch is that way. Like I pretty much only use touch to create new files. Like I said, it does have this side effect of updating metadata, specifically modification timestamps. And that's useful if you're like writing, you know, automations and you need to do that. But again, most of the time I'm just using touch to create a new file. All right. So to do it, you just touch, type name of file, it'll create the file. The file will be empty. Okay, you discovered a discrepancy with the credit card files. World Bank is supposed to be keeping credit history records, but they aren't there. Change into World Bank public products credit cards. All right, so cd .. This will take me up 2 directories. We're gonna go back down into public products credit cards. Create a new file called credithistory.txt. So touch credit history. .txt. Cool, so now we use ls to verify that the file was created. There it is, credithistory.txt. Paste the contents of the credit cards directory into the text field. So we'll just grab this whole thing and dump it into the input. All right, as we mentioned before, directory is just a location in a file system that can contain folders or can contain files and other directories. On some system, directories are called folders. Looking at you, Windows, but it's the same thing. So the make directory command creates a new directory inside the current directory. So during our digging, we found that a file appears to be out of place. Make sure you're in World Bank, public, products, credit cards. We are. Let me print working directory. World Bank, public, products, credit cards. We're good to go. Go back to the products directory, so cd ... Now that we're in the products directory, we'll create an investments folder. So make dir investments. List the contents of the products directory again to confirm it was there. There it is, investments. Paste the contents of the product directory in. All right. Good to go. All right, the move command moves a file or directory from one location to another. You can also use it to rename a file or move it into a different directory altogether. If you think about it, moving a file from one directory to another and renaming a file from the perspective of file paths is basically the same thing. And in a graphical interface, that's not necessarily obvious, right? You have to like drag the file into another folder to move it. Whereas renaming it, you can just like type in the new name. But when you're on a command line, you realize it's basically the same thing. All we're doing is changing the file path. Sure, that file path has directories that are changing, but like all that's happening is we're changing the path. And so the move command basically lets you change the path of a file, and it doesn't matter whether you use full file paths or relative file paths, both will work. So move the tbills.txt file from public products, credit cards, T-bills into public products investments. That's because T-bills are not credit cards, they are an investment. Okay, so from here, we've got credit cards and investments directories, so we can do move credit cards, T-bills to investments. Now, if we just do investments as a directory, it will automatically move it into that directory and keep the same name. But just, you know, because I'm the way I am, I like to be explicit, I'm just going to type out the whole thing. So we're moving it from credit cards, tbills.txt into investments, tbills.txt. List the contents of investments and paste the output into the text field. Good to go. All right, the remove command deletes a file or empty directory. Very straightforward. And the -r flag removes recursively, which just means that it'll go, if you try to remove a directory, recursively will also go remove everything that's in that directory. It's what happens by default if you're like in Windows Explorer or Finder and you delete a directory. By default in those graphical interfaces, it will delete everything that's inside the directory, as well as the directory itself. On the command line, it'll yell at you and say, you can't delete a directory unless you use the -r flag. It's kind of a safety mechanism because, you know, there could be 500 things in there. Did you really want to delete them all? So you've got to use the flag. Okay, change directories to World Bank private. So we need to go up to here and cd to private. Use the cat command to view the contents of the passwords file. So cat, we're in private, so passwords.txt. Why did I cd? I meant to, no, I catted. Okay, we're good. I catted. All right, there's a big problem here. It looks like someone is storing passwords in plain text. Oh, look at all these passwords. Delete both the passwords directory and the passwords.txt file within it. So let me show you what I meant. So if I do rm passwords, passwords directory can't do that. So we got to do rm-r passwords. Now the directory and the file is gone. List the contents of the private directory. We just did that. And we're going to paste its contents into the input field and move forward. Okay, the copy command does what you would probably expect. It copies a file from one location to another. So whereas the move command like removes the old file path, puts it in the new file path, this one will create a copy. And then you can also copy a directory using the -r flag. Of course, confusingly with the copy command, it's a capital R, whereas with remove, it could be a lowercase r. Take a look inside the World Bank private transactions directory. Should see a few files containing transactions from different years. All right, so should we just cd there? Let's just cd there. cd, private transactions, ls. All right, got some different years in here. Look inside the backup directory, ls backups. Okay, something's missing. What are we missing? 2020, 2021, 2022, 2023? Looks up like we do not have a backup of 2022. Okay. Copy the missing file from transactions into the backups directory. All right, so cp 2020.csv into backups 2020.csv. Now, if we ls backups, it's got all four. List the contents of backups. We already did that and paste it in. Home. I've already kind of mentioned the home directory a little bit, but now we'll talk about what it is. So in a Unix-like operating system, again, like Mac or Linux, a user's home directory is the directory where their personal files are stored. It's also the directory the user starts when logging into the CLI for the first time, which is why at the beginning of the course, we started in home, which is why the World Bank directory is inside our home directory. Personally, I recommend doing all your dev work inside your home directory. My personal convention, you can actually see it if I go here. I've got this workspace directory. All my coding projects go inside my workspace directory. Helps me keep everything organized. I don't have them kind of spread out all across my machine. Keeps all my coding projects in one place. Your home directory is where you want to spend most of your time. Already kind of mentioned this. And it can actually be dangerous to work in like other root level places on your file system. Places like /bin, /etc. Like the system uses those for specific things. So you don't want to go like putting your, cat photos in there if you can avoid it. And you can avoid it. Okay, so the tilde alias. So my home directory on Mac is located, like I said, at /user/wagslane. The tilde character is an alias for your home directory. This is true on both Mac and Linux. So if you want to go home, you can always type cd tilde. Tilde, you might not be used to typing tilde. It's perfectly normal. It's a weird character. It's just to the left of the one key at the top of the keyboard. It's the shift version of backtick. So anyways, and like I said, it's the alias for home. So what is the question here? What does the file path tilde/workspace/names.csv? So this is important. Like we talked about, absolute file paths start with a slash because slash is the root. Tilde/ is not the root. It's an alias for your home directory. So this is a workspace file. Nope. This is a names.csv file in a workspace directory, not in the root directory. Names.csv file in a workspace directory in the home directory. Names.csv file in a workspace file in the home directory. grep is very powerful. We're going to kind of briefly go over it, but it's a really powerful tool. And we're going to go over the basics, but it's something that you can just like always get better at using. And we'll even go into like chaining it with other commands later in the course. But okay, so you might be used to nice graphical interfaces that allow you to search for text in files. So if you've ever used Control F in a Word document or in your browser, or Command F if you're on Mac, it's how you can find text, right? Super useful. You've probably used it before, I hope. The grep command is basically the CLI's version of that, and it has tons of capabilities. We'll just be kind of going over the simple stuff. So the most basic usage for grep is to search for a string in a file. For example, if we wanted to search for the word hello in a file called words.txt, we just run grep hello words.txt, and it would print out every line in the text file that has that text, that word hello, in it. Applications often write their logs to files on disk. These logs can contain useful information about what the application is doing and can also be used to debug problems. As a security auditor, you need to dig through these logs to find any evidence of suspicious activity. Use the grep command to find any lines with the text critical, all caps, in the World Bank private logs 2024-01-10 log. All right, so World Bank private logs. So let's just go back into World Bank. We're going to do grep. We're grepping for critical. That's the text that we're looking to find. And then we'll pass in the path to the file that we want to grep within. In this case, private logs 2024-01-10.log. Boom. 4 lines. Now, just to show you what the full length of the file is, let's just cat it. So cat private logs 2024-01-10.log. It's huge, right? It's a very common use case for grep in production as a sysadmin, backend developer, whatever, looking through logs. Super useful. Can grep and find the stuff we're looking for. Cool. Paste the output of the grep command. All right, grepping multiple files. You can also search multiple files at once. For example, if we wanted to search for the word hello in hello.txt and hello2.txt, we just pass in the names to both files. All right, and then recursive search, we can also search an entire directory. Again, we just have to use that -r flag to say we want to search recursively, and then we pass in a path to a directory. And dot is a special alias for the current directory. So tilde is a special alias for the home directory. ... is a special alias for our parent directory, the directory up one level from where we're at, and dot is the alias for the current working directory. Use the grep command to find all the lines with the text critical in the entire logs directory. So now instead of this specific log file. We're gonna look at all the logs. So we're gonna grep -r, and we're gonna pass in dot for our current directory. Wait, no, we're not. No, we're not. Because we're not in the logs file. So we're gonna do private/logs because that's the relative path to the logs directory. There we go. And as we'd expect, we got some more because now we're looking through more log files. And then paste the output. Cool. Yay. All right, the find command. It's easy to get these mixed up when you're new to the command line. Grep is for finding text within a file. Find is for finding the files themselves. So with find, we can find a file by name. First, we pass in a directory, and then -name, the name of the file we're looking for. We can also do pattern searching. So star is a wildcard. So this command says, find inside of the sum directory, any file that ends in .txt. Because star could be anything. So it would match things like hello.txt, python.txt, anything.txt. It's gonna match all of those. Or if you're looking for example, just a word in the file name, you could do star name or word that you're looking for, star again. So it's like the file name can be anything, Chad, anything. Super useful. All right, you've been tipped off that fraudulent activity seems to happen often with joint accounts. Joint means accounts that have more than one owner. Use the find command to search the WorldBank public products directory for all files that contain the word joint. Okay, so we're gonna go find. We're searching the WorldBank public products directory for the name of files where they contain joint. So that means it could start with anything, then the word joint, and it could end with anything. Looks like we got 4 of them. Paste the output of the find command in. There we go. Let's go. Chapter 3, users. So Unix-like systems, like the one that we're using, again, Mac or Linux for the most part, they support multiple users. So as we've seen, I'm logged in as Wags Lane, that's my user. A bit of a history bit here. You know, it's pretty common that you're the only user on your machine. Like if you own your own laptop, you have your own work computer, very likely you're the only user on that machine. In kind of the modern world, we've pushed a lot of user accounts to the network, right? So you might have a user account on a website or on a local server, but maybe you just have your one account on your local machine. But historically, it was really common to have multiple user accounts on the same machine. I mean, it still does happen. It's just, you know, maybe not the case if you're using a personal computer. Long story short, the permissions that we're going to talk about here in this section are the permissions of the user on the machine. So, like, what am I allowed to do as Wags Lane? Like, that's what we're talking about here. And again, it can be a little confusing because it's like, if you own your own machine, it's like, well, it's just you. So you should have permission to do everything. And generally speaking, you do, but there's kind of this exception with the root user, which we'll get to. Okay, covered what users are. Let's talk about sudo. Now, it's very important that we pronounce it sudo, and it's very important because that's how I pronounce it. You'll hear other people pronounce it as sudo, and they'll have all these like really pedantic technical reasons as to why that's correct, but it sounds dumb. And because it sounds dumb, I think it's wrong. So I say sudo. What does sudo do? Well, you may have seen the jokes, right? Where it's like, make me a sandwich. No, sudo, make me a sandwich. Oh, okay, I'll make you a sandwich. That's kind of what it does. At the end of the day, it allows you to do things. That's like practically what it does. It allows you to do stuff that you otherwise wouldn't have permissions to do. Why does it allow you to do it? It seems kind of weird that just typing something in front of another command like gives you all these elevated users. Well, what it does is it allows you to like temporarily become a super user. So sudo stands for sudo, which stands for super user do. So it allows you to act as the root user. Very important note here, using sudo does grant unrestricted access and can risk system damage if you don't know what you're doing. So generally speaking, you shouldn't just like run commands as sudo. The naive thing might be like, oh, well, if like I just want to be able to do everything, I'll just run everything with sudo. That can cause problems because it doesn't just elevate your permissions, it also acts as, again, the root user. Okay, let's demonstrate that. So if I type who am I, I'm Wags Lane. If I type sudo who am I? First, I get prompted for my password. And also, it's important to understand that's part of the security mechanism. You can't just act as the root user anytime you want to on any user account. You have to have the root password. All right, now I'm root, right? I copy and paste the output of the command. Very good. In a Unix-based operating system like macOS or Linux, all files and directories have a set of permissions associated with them. Now, there are two ways that we break down those permissions. The first is who has the permission. The second is what permission do they have? Now, in regard to the what, any user accessing a file or a directory may or may not have access to read it, write to it, or execute it. Now, all of those permissions, both the who and the what, are represented by a 10-character string. The first character is always either a D or a dash. If it's a D, all that means is this is a directory. If it's a dash, it just means this is a file. The next three characters, RWX, represent the three permissions that we talked about: read, write, and execute. And the who that they apply to is the owner of the file or directory. The owner is usually just the user that created it, but it can be changed manually. Now, this RWX section can have several different states. Each permission can either be granted, in which case the letter is present, or it can be a dash, in which case the permission is not granted. So, for example, RWX means that the owner can read, write, and execute, while R-X means that they can only read and execute, but not write. And R dash dash means that they can only read. Finally, this set of RWX permissions is just repeated twice more. The next set applies to the group instead of the owner, and the last set applies to everyone else. So to break down a full 10-character string, let's take the example of D RWX R dash X R dash dash. The D means that this is a directory. The RWX means that the owner can read, write, and execute. The R-X means the group can read and execute. And the R-, just means that everyone else can only read this directory. Okay, so sudo allows us to do stuff because we act as the root user and the root user has elevated permissions. What are permissions, right? Well, in a Unix-like system, again, macOS, Linux, permissions control what we can do to which files and directories, and specifically, they're usually represented as this 10-character string. D, RWX, RWX, RWX. Okay, let's break down each character really quick. The very first character, the D, is just telling us whether this thing to which we can have permissions, whether it's a directory or not. So if it's a directory, it'll be a D. If it's a file, it'll be a dash. Those are the only options, really. The other 9 characters are really broken up into 3 groups: RWX, RWX, RWX. So the first 3 characters represent what the owner can do. So the owner of that file or directory, that's their permission set. The next is for the group, and the next is for everyone else. Okay, so this permission set, D RWX, 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 says this is a directory, and everyone, owners, groups, and others, everyone else, can all do everything. They can read, they can write, they can execute. That's what the R, the W, and the X stand for. If a permission is missing, it's represented with a dash. So for example, RWX is all permissions for that entity, right? Owner, group, or others. RW dash would mean not all permissions. It would mean that that entity, like for example, the owner, can read and write, but can't execute. Right, so they can read a script, they can write to a script, change the file, but they can't execute the script. Okay, those are the 3 types of things you can do with a file. So just really quickly, what is owner, what is group, and what is everyone else? Frankly, for most of us, owner and everyone else are probably the most important. I should say they'll probably be the ones you care about the most. So the owner permissions generally will apply to you if you're the owner of the file. I mean, they'd also apply to someone else if they created the file. Group permissions, I won't go too in depth here. Long story short, you can have groups of users if you do have multiple users on the same machine, and that's what those permissions apply to. Generally speaking, if you're just doing local development work on your own machine, or even if you're administrating a server, you typically won't need to worry about group as much. And then everyone else is exactly what it sounds like. It's everyone else. For example, putting RWX, read, write, and execute for everyone else just means literally anyone can do all 3 of those things. So That's usually one that you really have to worry about, especially if people are able to access your machine over the network, like in the case of a web server. Again, this isn't a course on web servers. I just want you to understand the permission string and what it all means. Actually, like understanding the security ramifications, especially for like web servers, is really a whole nother can of worms that I don't want to get into. I want you to understand in this chapter the permissions you have on your own machine when you're doing like local development and you're installing tools and you need permissions to use those tools. Okay, so what is the question? Which permissions allow everyone to read? Okay, well, it's not this one because it goes owner, group, everyone else. So this is everyone else has no permissions here. In this one, we've got the owner has all permissions, the group can execute, and everyone else can execute. In this one, we've got the owner has all permissions, the group can read and execute, and everyone else can just read. So it's looking like that one. And then just for completeness sake, looks like on this one, the owner and the group have read, write, and execute permissions, and everyone else can do nothing. So it's going to be this one here. All right, another question. Which permissions allow the owner to execute? All right, well, this gives all three groups read-only access. This one is owner is read and execute, group is read and execute, and everyone else is just read. This one is read write for owner, read write for group, and read only for everyone else. And then this one is read write for everyone. So the only one of these where the owner is allowed to execute files is this one here. Changing permissions. Okay. So the chmod command is what lets us change permissions. So you'll probably use chmod quite a bit if you're working on a terminal. It is kind of annoying that it's called chmod. It stands for change mode. It would be, again, this is like one of those naming things like cat. All right. As part of your security audit, you need to know who has access to the files in the private directory. The ls command has a -l option that will print out the permissions of each file and directory in long format. Okay, list the files in worldbake/private. So we'll do ls-l private. So here we can see the permissions get printed when we use the -l flag off to the left-hand side. Very useful. Change the permissions of the private directory and all of its contents so that the owner can read, write, and execute. The group can do nothing, and others can do nothing. Okay, so it looks like right now we've got read, write, execute for owner, rx. All right. So we're going to chmod -r to get the directory and all of its contents. We're going to set the, let's see, we want the owner to read, write, and execute. So u equals rwx, comma, g equals nothing for group, and others is also nothing. And then the directory is private. Okay. Once you've changed the permissions, run the ls-l command again to make sure they've updated. Perfect. Paste the 10-character permission string of the updated private directory. All right. And if we want the private directory, right now we're looking at its contents. I mean, they should be the same, but we can just do ls-l here and take a look at the permissions of the directory itself. So we'll grab that and paste it in. All right. So should be very familiar with the idea of reading and writing files. Reading a file, very, very self-explanatory, right? You cat a file, that's reading the file. Same with head and tail, grep. These are all ways we read data out of a file. Doesn't matter which program we are using to read the file, right? Again, cat is just a program. Head and tail, they're just programs. Microsoft Word is a program. The point is, if you're able to get the data out of the file, that means you have read permissions, or you need read permissions to do that. And then you need write permissions to be able to change the file or update it. Executing a file is exactly what it sounds like. It's like, can you run this file as a program? Can you send the data that's stored in the file through the CPU as instructions and do something? Right? And it's important that that permission is different because, I mean, that's basically all the protection you have against malware. You don't want files that you don't trust to be allowed to be run. That's like how computer viruses spread. So Or I should say that's how they run. Okay, cool. So files with a .sh extension are called shell scripts. They're just text files that contain shell commands. So like all the stuff we've been running in our terminal, in our shell ZSH, we could put that in a .sh file. It doesn't even really have to have that extension. But the point is we could put that all in a file and we could execute that script. And our shell interpreter, ZSH in the case of Mac or Bash on Ubuntu, will execute the commands in the file. And then this is just explaining how to run a program. So in order to run a program in a shell like ZSH, all you need to do is type the file path of the program, with the exception that if the program is in the current directory, you do need to explicitly use the current directory alias, which is dot that we covered a while ago. If it's not in the current directory, then you don't need to worry about that / prefix. All right, on to the assignment. So there seems to be a suspicious script in the World Bank private bin directory called genids. Let's go there. Genids, there it is. Run the following commands in World Bank private bin. Chmod -x genids, okay? Chmod -x genids. That removes the execute permission. Let's test those permissions. Try to run the script. Let's run genids. Permission denied, right? Because we removed our own permissions to run it. Okay. So that error occurs because the executable permission is not set for your user, the owner, Wags Lane in this case. Let's re-add the executable permission. So chmod +x genids. This is very important. As a developer, you'll run into this all the time, where you download a script from online or you write a script yourself and you save the script or the file or the program, and then you go to run it and you get permission denied. And so many new programmers like, permission denied, like what? And they go to Stack Overflow and they're Googling things. It takes them a while to figure out. 99 times out of 100, you just need to chmod +x it. Just chmod +x it. Chmod +x file name. That'll give the user you're currently acting as permissions to execute. Very, very useful. Use it all the time. Okay, so once we've done that, let's just run it again. And it runs. Perfect. Paste the output of the script into the input field and submit. Deal. Root user. Okay, so I kind of talked a little bit about the root user. I skimmed over it. Let's talk about what it actually is. And here's that XKCD, that awesome XKCD comic that I was referring to earlier. The root user is a super user, right? Super user do. It has access to everything on the system and can do anything. When you use the sudo command, you're running as the root user, as long as your system hasn't been configured differently. Just like everything in programming, there's always weird exceptions, but generally speaking, that's what's happening. The sudo keyword is convenient because it quickly gives you elevated permissions to run a single command. So like you can actually change to the root user like permanently in your shell session, but usually you don't want to do that. Usually you just want to like run as root for a second. So, however, it can be dangerous because it gives you access to everything. If you run a command with sudo that you don't understand, you could do serious damage to your system. For example, rm with the R and F flags. So rm-rf, let me clear this up. rm-rf, or if you're Gen Z, rm-for real, will delete forcefully and recursively. So if you do rm-fr or rf / this could delete literally everything on my machine, including all the system files that my operating system needs to run. So like, don't do this. Now, luckily, I'm not even going to try it because like this scares me. If I ran this, probably nothing bad would happen because there's safeguards put in place that basically like stop you from doing this and like give you an additional prompt. For example, in a lot of systems, you need to use the -- no preserve root flag in order for it to work. And when we didn't put this in here, a bunch of people hopped into the course and were like, actually you need to use the flag. It's like, okay, yeah, but just don't fucking do it. Like, just don't do it, right? Good to know. Good to know. rm-rf, very dangerous. And you would need to, as the whole point of this lesson is sudo rm-rf /. That's the really scary one. Again, there's still some safeguards, but like the point is sudo will let you do crazy dangerous things. So just be careful. All right, let's answer the question. Which is a super user? Root, Chuck Norris, administrator, admin. It is root. You can think of root as like the actual user, and super user is like a type root is a type. Root is an instance of a super user. Super users have elevated permissions. The next question is, what happens if you run sudo rm-rf/? Your computer will be wiped clean of all files, including files needed to function. Yeah. Your computer will be wiped clean of all files, but will still function normally. No, probably not. You will lose your collection of dank memes. Everything else will be fine. Wrong. Somewhere in the world, Linus Torvalds chuckles. That might happen, but no. The computer will be wiped clean of all files, including files needed to function. Again, with the caveat that maybe you need that no preserve root flag. That's kind of a newer thing. You didn't need that on older machines. Chown. Okay, so if chmod changes permissions, chown changes owner. So when do you need to use sudo? Well, chmod allows you to change the permissions of any file or directory that you own, but it would be kind of weird if you could just change the permissions of files that other people own. Like, that doesn't make any sense, right? Like, you need to be authenticated as a user in order to change permissions for that user's stuff, right? So that's what chown is for. It allows you to change the owner of a file or directory. So let's see what this looks like in practice. Where are we? We need to go into the private directory. Can I make this any bigger? Oh, I can make it a little bigger. Look at that. Go into the private directory. Take a look at the contacts with ls. All right. See a directory called contacts. There it is. Take a look at its contents. ls contacts. There's an emergency.txt file in here. Let's cat it. Cat contacts emergency. All right. Looks like there's some emergency contacts in here. It seems like it has some personal contact info for employees. We don't know whose this is, but we're pretty sure it should have access. We're pretty sure it should have access strictly limited. Okay. Let's change the owner of the entire contacts directory to root. Got it. So because this is an important file, instead of my personal Wags Lane user owning it, we want root to own it. So we're going to do that. So first I'm going to go ahead and ls-l, and you can see the contacts directory is owned by me. So we got permissions over here to the left, and then we've got the owners. And by the way, if you were curious about group, I am part of the staff group. That's why that's showing here. Okay, so we're going to go ahead and change it to root. So sudo change owner recursively, because we want contacts and everything in the contacts directory, and we're changing it to root, and then the path to the directory itself. Gonna need to enter my password because I'm acting cool. Now if we ls-l again, it's changed, and everything inside should be changed as well. Well, we're going to get to that. Pretend I didn't just do that. We're going to get to that. Okay. Paste only the line from the output that represents the contacts directory. All right. Boop. Copy that into the input. All right. Before you start this assignment, make sure permissions on the World Bank private contacts directory are drwx, that the owner is root, and that you're not signed in as root. So we should be good here, right? Let's just go through all of that again, just so that you can kind of follow along. So ls-l. So contacts directory, it has drwx as the permissions. The owner is root. And who am I? I am Wags Lane. I am not root. Okay, so we're good. You've told senior staff about the contacts directory and its contents, and they've decided to delete it entirely. Go ahead and try to delete the contacts directory with the rm command. So rm-r for recursive, contacts, permission denied. As expected, it's failed to delete because we're no longer the owner. And if we look at our permissions, only the owner has write permissions to be able to delete the file. We are now essentially part of other. Well, actually, that's not entirely true. We are part of the staff group, but also the staff has no permissions. So the point is we have no permissions. So let's try again using sudo, because if we act as root, root is the owner, so we should be good to go. Sudo rm-r contacts. Deleted. Once you are confirmed you're able to read it, run the ls command from inside the private directory. Paste the output. Ta-da! A program is just a bunch of instructions written in a way that a computer can carry out. And in a nutshell, there are two kinds of programs: compiled programs and interpreted programs. For our purposes, the real difference between the two is just that compiled programs do not rely on any other programs to be able to run. They're usually written in a language like C, Rust, or Go, but are then compiled down to binary, the raw language of your computer's hardware. Interpreted programs, on the other hand, do require other software in order to be executed. Python, Ruby, JavaScript, or shell scripts rely on an interpreter to read the code as they run. When you run a program on your machine that has no other dependencies, it can simply be ran by typing the name of the program into your shell. However, when you run an interpreted program, you need to tell your machine which interpreter it should use. For example, to run a compiled program called text editor, you might just type /text editor. To run an interpreted Python program, you might have to type python texteditor.py. And that's because the first one is a compiled binary. It's just ones and zeros that your machine knows how to execute. In the second example, texteditor.py is just a file of Python source code, so it needs access to the Python interpreter. All right, compiled versus interpreted. So programs are just sets of instructions that a computer can execute. And sometimes we call those programs, sometimes we refer to the programs themselves as executables. An executable can be like a thing, like an actual program. It can also like be an adjective to describe something. Like it's executable, we can execute it. So it could be a noun or an adjective. But the point is, sometimes the words program and executable are used interchangeably. And broadly speaking, there are two types of programs. There's compiled programs and interpreted programs. Compiled programs just means any program that has been converted to machine code such that it can run directly on your computer's hardware. It's the language of your computer's hardware is probably the best way to put it. The instruction set that your computer's CPU is designed to execute, that's the format of the file. And it's not human readable ever, basically. It's ones and zeros. It's binary. You'll also sometimes hear compiled programs called binaries. Like, hey, can you run that binary? A way people talk about compiled programs sometimes. Interpreted programs, on the other hand, I mean, they still run through your CPU at some point, but they're not compiled to natively run on your hardware. There has to be another program running that interprets the code. Typically, interpreted programs run a little bit slower, but they also have some other benefits, like sometimes they're more cross-platform because they don't need to be compiled to a specific architecture. So what's the difference? All right, and let me give you some like concrete examples. So if you've ever played a video game on Windows, you're probably used to opening a .exe file. .exe files on Windows are typically compiled executable files designed to run on your computer's hardware. Well, again, typically, there's always exceptions, but like that's probably what's happening here. On Linux and Mac, you will not often see the file extension .exe. It's not necessarily that there's like rules against it, but you don't usually see that. It's not really the convention. Video games are often compiled programs. Interpreted programs, on the other hand, are things like shell scripts, like the genids.sh. That's an interpreted program that is run by the shell programming language, in my case, ZSH. Python is another example. When I run a Python script, you not only have to run the Python program, you need to run it using the Python interpreter, which is why to run a Python program, you have to type something like Python main.py. Typically, you have to say, hey, I want to use the Python interpreter to run this file. Whereas with an executable file, you could just run it directly. If you're paying really close attention, you might have noticed, wait, I can just run scripts like shell scripts without having to specify an interpreter. That's true, you don't have to specify it necessarily, but there still is an interpreter being used under the hood, right? In the case of ZSH, it's the ZSH interpreter. Let's get to the assignment. In your shell, run the following command. Which sh. Take a look at the contents of that file. All right, let's cat /bin/sh. It's terrible. Why? Why is it terrible? Probably because it's a compiled program. All this crap is binary data. You can see there's some stuff in here that we can interpret as text, but there's a lot of just like binary in here, I think. So long story short, this is a compiled program, sh. Whereas the like genids.sh script that we were reading before was a script. It was just a plain text file. These are both executable programs, the sh interpreter and the .sh script, but the .sh script needs the interpreter in order to run. because it's interpreted. Okay. Answer the question. What is the output of catting the sh executable? Raw binary encoded as text in hexadecimal. Raw binary encoded as text in ones and zeros. Nothing. A bunch of gibberish. Raw bytes attempting to be interpreted as text. It's mostly this. Mostly a bunch of gibberish. Next question. Which can be executed without the help of an interpreter? A shell script like genids.sh? No, it needs the sh interpreter. A compiled executable like the sh program? Yes. A Python script? No, needs the Python interpreter. Shebang. Okay, so as we talked about before, you can run any executable file by typing its path in your shell, like bin/genids.sh. That works out of the box for files that are compiled executables, of course, but interpreted programs, that doesn't always work out of the box for. Like we mentioned before, sometimes you'll need to specify the interpreter, but there is this little trick called the shebang where you can add the interpreter basically on like the first line of the script to say, hey, when I run this script as an executable from my shell, here's where you can go find the interpreter to interpret it. That way you don't need to specify the interpreter on the command line when you run it. So you can specify the interpreter in the script itself. Cool. So like, for example, this says, hey, use the Python 3 interpreter when I run this script. Now, instead of having to type Python 3 main.py, I can just type /main.py. And because the main.py file has the shebang as the first line in the file, we'd be good to go. Use the cat command to view the contents of private bin genids. So cat bin genids. See, we got a shebang up here. Paste the shebang into the input field and submit your answer. Bourne shell. Okay, so as we talked about before, if you are on Windows, then you should be on WSL and you should be on Ubuntu, which means you're probably using a bash shell. And if you're on Mac, you're probably running ZSH. Older Macs, you might also be on bash. They kind of switched to ZSH by default. I can't remember, a couple of years ago. If you're running a raw Linux installation, something custom, then I hope you know what you have, because I don't. So to get hand wavy about it, I want to explain the difference between bash and ZSH. Like I mentioned at the beginning of this course, the differences are not so great that you will typically notice if you're just doing like what I would consider like standard web development stuff. But the differences will become apparent if you're doing like a lot of heavy scripting, because they are different scripting languages. Okay, so what is SH? SH is the Bourne shell. It's kind of the original, the OG shell language. It's the original Unix shell, and it's POSIX compliant, which is a fancy way of saying like it adheres to a strict set of rules that it kind of ensures that the script will behave in a certain way. So like there's certain syntax that it has to support, and the Bourne shell supports that syntax and those rules. It's a very basic shell, and it doesn't have very many quality of life features. So writing really complex scripts in straight SH can get really verbose. It means it requires a lot of code to do it. Bash and ZSH are newer shells that have a lot of quality of life features. So, when you are writing more intense scripts, it can be really helpful to be using Bash or ZSH because you get kind of additional features. Features on top of just like your standard POSIX compliant stuff. So Bash stands for Bourne Again shell, and it's generally speaking the most popular shell on Linux. It builds on top of SH, but adds a lot of features. And then ZSH, or the Z shell, currently the most popular shell on Mac. It's similar to Bash in that it adds extra stuff on top of SH, but it's just different than Bash. Okay, now ZSH and Bash are both SH compatible, which means ZSH and Bash can run .sh scripts. They can run scripts that are kind of Bourne shell or POSIX compliant. They just have extra features on top. Again, for the purpose of this course, you don't need to know big differences between them. Just know that they are, in fact, different. Question. Blank and blank are a superset of blank. They can do anything blank can do and more. ZSH and Bash, Bash and ZSH are a superset of SH. They can do everything SH can do and more. All right, shell configuration. Both bash and zsh have configuration files that run automatically every time you start a new shell session. Selly shells, she shells by the seashore. These files are used to set up your shell environment. They can be used to set up aliases, functions, and environment variables. So we went over variables a lot earlier. We'll talk about environment variables later. Point is, it's kind of like, have you ever set up something to run on startup on your computer? For example, like I have Spotify open every time I open my computer. This is the equivalent of that. It's like, do you just have certain scripts that you want to run when you open a shell session? That's what these config files are for. They're very useful. The configuration files are always located in your home directory, so it'll be specific to a user and are hidden by default. So for example, if I ls-a my home directory, you can see, so -a shows like hidden files. You can see there's my zshrc. So zshrc.zshrc, is the hidden file. The dot means it's a hidden file. That's the one that's going to run every time I open up a new ZSH shell. All right, as part of our audit, we're trying to figure out what shell commands run automatically when a user logs in on the machine. So we need to confirm which shell configuration file is being used. Edit the file you believe to be your shell configuration file, in our case, zshrc. And we can use the nano command to do it. So we're going to go nano home directory.zshrc. Edit the file you believe to be your shell configuration file and add the following line to the bottom. So I'm just going to use the arrow keys like a simpleton to go all the way down to the bottom. And we're going to echo hello from the shell. And then I'm going to Control O, enter, and Control X to exit. All right, close your terminal and open a new one. If you see the message hello from the shell, you found the right file. Do I have an easy way to file? Does Ghosty? I'm sure Ghosty has an easy way to, oh, you know what I can do? I think I can open a new tab. Perfect. There it is. Hello from the shell. So right when I opened a new terminal tab, which opens a new shell session, we got this hello from the shell printed. Edit the bashrc again to remove the line you added to the file. Okay, let's go ahead and do that. We can, I don't even know the command in Nano to delete a line, so I'm just gonna backspace nice and slowly. All right, Control O, save, Control X. Now when I open a new tab, it's not printed, so we successfully removed it. All right, answer the question. Why might you restart your shell after changing a shell configuration file? Because the config file runs when you type ooh senpai please? No. Because the config file runs automatically when you start a new shell session? Yes. So we talked about how you can create and use local variables, name equals lane, echo name. There's another type of variable called an environment variable. Frankly, you'll probably use these more often. They're available to all programs that run in your shell. So very often you will create environment variables and then run programs that use those environment variables as they run. A very common way to configure a program on a server, for example. You can view all of the environment variables that are currently set in your shell with the env command. I'm not going to type it for you because it probably has private stuff, probably has some secret keys in there. I'm not going to do it. So to set an environment variable in our shell, we use the export command. So the only difference here is that we're going to use the export command. And then kind of by convention, environment variables should be screaming case, all capital letters. So for example, export name equals lane echo name. And again, the difference here is that programs can read the environment variables. I've exported it. Okay, assignment. Take a look at the contents of warn.sh script in worldbink private bin. Are we in bin? We need to go to bin, cd bin, cat warn.sh. Okay, so you can see our shebang at the top, and then you can see it's actually using some environment variables here. It looks like it's using one called warn message and one called warn from name. So we need to export those before we run it, because let's just try running it right now. If I just run warn.sh, you can see this line is blank and the from line is blank because there's nothing in those environment variables. So first, we're going to set export warn message equals the auditor is here. What do I do? Export warn message equals the auditor is here. What did I screw up? ZSH bad assignment. What am I doing? There we go. No spaces allowed. Export warn from name equals Your worst nightmare. Now we run it again. There we go. And you can see the variables are used. The auditor is here and from your worst nightmare. Run the script and paste its output into the infill field. We can do that. Path. Okay, this is one of the most important lessons in the entire course, honestly. So really the purpose of this course is to get you comfortable using your command line. There's a few lessons in this course that are going to come back and help you over and over and over. Chmod plus X is a big one. Just understanding environment variables in general, file paths. But the path is a really important one anytime you're trying to install tools on your machine. And I have seen developers with years of experience still get confused about their path and what is installed on their machine. So let's understand what it is fundamentally, so when you do have issues in the future, which you will, you know how to debug them. There are environment variables that are sort of built into your shell. And by built in, I just mean there are programs that care about those environment variables by default. Kind of like how this warn sh script wanted warn message and warn from name. Those are weird. We made those up for the script. There are other environment variables that, like all programs or many programs, care about. Path is one of those environment variables. So why do we care about path? The path is an environment variable that stores a list of directories. Any file in any directory in that list can be run straight from the command line without having to type the full path. So, for example, cat is a program, right? We've been using cat all the time. If I do which cat, we can see the absolute path, /bin/cat. Bin is a directory in my path. What that means is when I just type cat without typing the full absolute file path to cat, it works because the bin directory is being scanned for executables called cat. So when you install programs that you want to be able to use system-wide, you want to be able to run them on the command line just using their name from anywhere, then the directory that that program is in needs to be in your path. Let's take a look at our path. A lot of stuff in here. What is it? So bunch of absolute paths, /users, /wags lane, /bun/bin, colon. Okay. The colons are the delimiters in your path. So this is an absolute path to a directory. Anything in this directory, I am able to execute, provided I have permissions, by just typing the name of that program into my shell. So I don't have to type /users, /wags lane, /bun, /bin, warn.sh. I can just type, in this case, warn.sh, assuming it's in there. And then we have a lot of those. We have a lot of those directories in the path. So why does this all matter? Well, a lot of times, again, you'll install a tool and it'll go somewhere on your machine, and that somewhere, that directory isn't in your path. And so when you go to run it, try to run it, the machine will say something like, command not found. And you go, why is it not found? I just installed it. Well, it's because the directory it was installed into is not in your path. So, as something of a security engineer yourself, let me clear this up. You want to temporarily disable the path variable so that you can only run executables by using their full path, just so you don't accidentally run something you don't mean to. So, reset your path variable to an empty string. Go ahead and do that. Sweet. This will only affect your current shell session. If you open a new shell, it'll still use the default. So that's great. Try running some simple commands. Yeah, let's ls. Oh, shoot. Can't ls. Why? Because the /bin directory is no longer in our path. So it doesn't know where to find ls. I mean, same with print working directory still works. Sorry, there are some that are like truly built in. Some will no longer work while others that do not rely on the path will. Then we answer the question. After deleting your path, what happens when you try to run ls? The command isn't found. Change your path. A common problem you'll run into in the future is that you install a new program on your machine, but when you try to run it from your terminal, you get an error like command not found. We just talked about this. 9 times out of 10, that's because the program is installed in a directory that's not in your path. So when you install stuff, maybe you're apt-get installing on Ubuntu, right? Maybe you're brew installing on Mac. Maybe you're literally downloading a binary with curl and trying to run it. Almost always, if you're using some sort of installer or package manager, during the installation process, usually toward the end of the installation process, it will print out where it installed the thing. And then it'll say, try running the thing using this. So many programmers, I mean, I'm guilty of this as well. When you're running like installation commands on your terminal, it like spits out all this text and you kind of let your eyes glaze over. And then it finishes and then you like try to do it and it's like, oh, command not found. You're like, oh, it's broken. You go straight to Stack Overflow, straight to Google or straight to ChatGPT. When often in that text, it probably told you where it installed the thing on your machine. And if you know that it just needs to be in your path, then you can just go check like, is that directory in my path? Oh, it's not. You add it, and then you're good to go. So that's usually how that goes. Okay, restart your shell session to reset your path. Give me a new shell session. Make sure I got my path back. We're good. The World Bank directory that you downloaded has some executables that would be useful to have in your path so you can run them from anywhere. Add World Bank private bin directory to your path. So we're gonna go to bin, and then I'm gonna print my working directories. This is the full absolute path. And now we're gonna add it. We're gonna add it to our path. I'm gonna do it the manual way because I think that's more important to understand. It's definitely more illustrative. So export path equals, so we're setting the path environment variable. And this is important. First, we start with the old path. So we're saying the new path is gonna be the old path plus the colon delimiter and the new directory that we're adding, right? Because if we just set it to the new directory, we'd lose all the other directories that were in our path. So go ahead and export that. Now, cd outside of the World Bank directory entirely. In fact, let's go home. Cd home. Now run worldbank.sh. So just to show you, we ls here, you can see worldbank.sh is in here. So normally to run this, we'd have to give the full file path. So like worldbank.sh like that. But now, oh crap. Ha! Oh wait, no, I didn't start a new session. We're good. I just cleared. We're good. But now because it's in my path, I should be able to just type worldbank.sh. And it still works, even though I'm in my home directory, because that directory that it's in is now in my path. Follow the prompts and copy paste the entire interaction. All right, enter my name, Lane, enter my email. Ooh, I don't want to show you my email. Lane at gmail.com. It's not my email. Got him. All right, copy that whole interaction. Good to go. Path config. In the last lesson, you changed your path variable for your current shell session. The trouble is, the next time you restart your shell, it will be reset to its default value. You won't be able to use worldbank.sh from anywhere unless you change your path permanently. So just to show you what I mean, if I open a new terminal and run worldbank, oh my gosh, .sh, wait, sorry, not ./ What am I doing? Let me just type it out. Worldbank.sh, command not found. New shell session, my path environment reset. Edit your ZSHRC and add an export command to the end of the file. So this is a very common use case for configuration files like .zshrc. They'll have commands in them that modify your path because that's how you modify your path permanently. So let's go ahead and nano ZSHRC. All right. And the instructions say to do it at the end of the file. It probably doesn't matter where you do it. I'm just gonna go ahead and do it at the end of the file. Okay, so here we're gonna run the same command. So export, it's the exact same thing we typed into our shell. So export path equals $path thing we want to add, which, oh, if I could remember what it is. It's users, wags lane, then worldbank private bin. And then we'll Control O to save, Control X to exit. All right, now restart our shell session. I'm gonna use a different method here. Instead of opening a new terminal window, which I could do, but you've seen me do that before, I'm gonna source the ZSHRC file. This is a way to rerun that file without actually starting a new session. Now that I've done that, my path should be updated. Let's go ahead and try to run worldbank.sh, and it worked. What changed when we added the path change to the config file? We need to use the full path to worldbank.sh. No, that would be silly. The worldbank.sh script is available from anywhere, even after a shell session restart. Correct. The worldbank.sh script is available from anywhere, but only in the current session. No, the point of adding it to the config file is that now it's always available. So again, when you install stuff and then you want to use it day to day, you're probably going to want to edit your ZSHRC or bashrc, or in some distros bash profile or whatever. Okay. Chapter 5. Okay, the man command is short for manual. And it's a program that displays the manual for other programs. Now, I know that manuals and documentation can feel scary. They can feel intimidating. RTFM, read the friendly manual. It's daunting. That's why tutorials and courses and things like this even exist, is because reading the manual can be scary. But my goal with all of these courses is always to wean you off the hand-holding slowly over time, so that by the time you're done with the courses, you feel really comfortable just looking at documentation and figuring things out on your own. That's really what it means to be a professional developer. That doesn't mean you can't take courses as a professional developer, but it does mean you shouldn't need them, right? Maybe they can save you time, they can get you up and running faster, but you should be able to read documentation. So, using the man command, well, all you do is type man and then the name of a command. Now, of course, not every command or program out there has a man manual, but a lot of the built-ins do. So if you're using kind of the traditional Unix programs, there's likely a manual entry. So manual itself has a manual entry. So man. This is what a manual looks like. You usually get this interactive pager. We're familiar with this, right? From the less tool, for example. Enter moves us down a page, Q quits, all that good stuff. Now, most people don't just read manuals for fun, like TJ did with the NeoVim manual and Sarah did with the Bash manual. Most people don't do that. We reference the manual when we need it for specific things. So, for example, I can open up the manual for the ls command, and say I want to know what the -r flag does. This is really common. You look up the manual for a command to see what flags are available to you. Type / to say, hey, I want to search, and then I'm searching for -r. Hit enter. There it is. So -r reverse the order of the sort. Very cool. That's what -r does. All right, and then I can use N to jump to more results. So there's another -r in here. There's another -r in here. Great. Q quits. Perfect. Let's jump to the assignment. As a systems person, the grep command will be your best friend. It has a lot of power, but it can be a little confusing to use. Open the grep manual. So man grep. Cool. Read the first couple of paragraphs of the grep manual and answer the questions. I'm just gonna RTFM. I'm just gonna read you the first couple paragraphs. All right. The name of the command is grep. There's also all these other types of grep. egrep, fgrep. Cool. Very good. It's a file pattern searcher. This hairy syntax is representative of all the options, the things that you can pass into grep. Not going to cover that syntax right now. It's not as scary as it looks, but it's also not really the purpose of this course. But this is basically telling us how we can pass arguments into the command, and we will cover arguments and stuff just a bit later. Cool. Description. The grep utility searches any given input file, selecting lines that match one or more patterns. By default, a pattern matches an input line if the regular expression, RE, in the pattern matches the input line without its trailing new line. An empty expression matches every line. Each input line that matches at least one of the patterns is written to standard output. So, a lot of words to say what we already know, which is we can search through a file for an expression, a string of text, and print all of the lines containing that text out to standard out. Grep is used for simple patterns and basic regular expressions, BREs. Of course, we need an acronym. egrep can handle extended regular expressions, EREs. fgrep is quicker than both grep and egrep, but can only handle fixed patterns. Fastgrep. Patterns may consist of one or more lines, allowing any of the pattern lines to match a portion of the input. All right, let's go ahead and see what the question is. What does the -v flag do? Holy crap, we didn't even get to -v. All right, let's search for it. /-v. All right, now it's lowercase v, so lowercase v is invert match. Selects non-matching lines. Selected lines are those not matching. That'll be it. Getting chests, getting achievements, awesome. All right, next question. Which option is incorrect? -t, -r, -i, and -c. Well, let's see. What's the first one? -c? Let's look for -c. -c is count. Okay, that looks correct. What's I? I is ignore case. Okay, that's good. And then -r is recursive. Okay. -t, st, there's no t. there's no T. It's that one. Cool. Now we know how to use man. All right. Flags. All right. Now we're going to talk just a little bit more in depth about all those options that we can pass into a command. So as you've already seen in this course, some commands accept flags. Flags are options that you pass to a command to change its behavior. For example, the ls command can take the -l flag to show a long list of files, right? We've been here, ls-l. Or the -a flag to show all files, including hidden files, ls-a, right? And you can combine flags. When you combine flags, you can combine just the letters and you don't need to type extra dashes. So ls-al or ls-la, both, ls-la, they do the same thing. Or you could do ls-l-a. Again, does the same thing. Cool. Now, whether or not a command takes flags and what those flags are is up to the developer of the command. That's why a manual is useful. There's no there's conventions, right? Like -r oftentimes will be recursive, but it doesn't have to be. So you need a reference or to just test it out. Now, single letter characters are typically prefixed with a single dash, like ls-a. Oftentimes there's a more verbose version. So let me man grep again. So you can see the -a flag also has a long version, which is --text. So typically the long version is --. The short version is single dash. What I recommend is when you're typing the command kind of manually in your terminal, you're probably going to want to use the short version, like -a or -b. When you are writing a script that calls a tool like this, that's when I'd use the verbose version, like --text, or in this case, --byte offset, just because it's clear. So when someone else reads your script, it's more obvious that --byte offset has something to do with a byte offset than just -b. So you just use -b when you're trying to save yourself time. Use the longer one when you're writing a script that maybe you're going to commit to source control or you're going to share with teammates. Cool. You found that some files have been tampered with. To figure out which one it is, you need to know the number of bytes contained in each file. Use the word count command, wc. We have wc, right? Which word count? It's under user bin wc. Cool. To count the number of bytes in the World Bank public PR ideas text file. Use the man command to figure out which flag you need to use. Cool. So it's man word count. We're trying to find a flag that will give us the number of bytes. And my eyes luckily just immediately saw this. The number of bytes in each input file is written to the standard output. This will cancel out any prior usage of -m, which I'm guessing is, the number of characters. Okay, cool. So by default, WC counts words. Word, line, character, and byte count. Default is words. We want bytes. Let's do it. So word count, -c, World Bank, public, PR, ideas.txt. 1098 bytes. If I don't use that flag, then, actually I get, I guess by default I get all of them. So 12 words, 182 characters, 1098 bytes. Paste the number of bytes into the input field. Awesome. Positional arguments. Okay. So flags, the interesting thing about flags is that the order doesn't matter. We can do ls-al. Again, we can do ls-la, and we can do ls-a-l. It all works. Positional arguments, the order does matter. Just like if you're familiar with Python, Python functions take arguments, and the order matters by default if they're regular arguments, if they're not keyword arguments. You can almost think of, again, if you're familiar with Python, flags are basically keyword arguments and positional arguments are regular command line arguments. So for example, the move command, right? We've already been here, or the ls command. So ls by default prints the current working directory, but it takes as its first positional argument the name of a directory, like World Bank. Okay, take a look inside World Bank public directory, cat the contents, let's go there. cd World Bank public, cat the contents of key.txt. Ooh, scary private RSA key. Move it from World Bank public key.txt to World Bank private. All right, so we're gonna move key.txt to // need to go up a level, private key.txt. And then we're going to ls the dash dash private. ls the private directory and paste the contents in. So just again, to be clear, the move command took 2 positional arguments. The first is the source. The second is the destination. Those are not flags. Those are positional arguments. Paste that in. Good to go. Help. By convention, most production-ready CLI tools have a help option that prints information about how to use the tool. Very common. It's usually accessed with one of the following: -- help, -h, or help. Very, very common. It's almost always one of those 3 things. I hope it's never not one of those 3 things. Cool. The help output is often easier to parse than a full man page. Yeah. So with built-in Unix commands like ls, cat, things like that, it's much more likely, first of all, that there's going to be a help command for it than there's going to be a manual entry. That's just more likely because it's easier to ship documentation with the program than it is to get a man page. So go there. Also, the help, in my opinion, usually tends to be more concise. So if what you're looking for is fairly simple, you'll probably find it more easily in the help flag. Okay, you need to make some network requests as part of this audit. You want to make sure that this machine you're auditing only has access to authorized systems. To make those requests, you'll need to know how to use curl. It's a CLI tool that lets you make network requests from the command line. Print out the help menu for curl. All right, so we're just gonna guess. I don't even know. I'm just gonna start with -- help. There it is, -- help. Man curl, much bigger, see? Lots of stuff in here, but curl -- help, very simple, very concise, gives me kind of the simple version of the usage. All right, paste the command you use to print the menu into the input field. So we just did curl -- help. Awesome. Exit codes. Exit codes, sometimes called return codes or status codes, are how programs communicate back whether they ran successfully or not. 0 is the exit code for success. Any other exit code is an error. This is very important. 0, good. Everything else, bad. And 9 times out of 10, when it's a non-zero code, it will just be code 1. Those are the 2 most common codes, just 0 and 1. Of course, there are other codes. Those are the common ones. Those are the popular ones. So you might think why do I care about these exit codes? I can tell whether or not my command worked just by looking at the output. And that is generally true when you're just working on the command line. But a lot of times you'll call a program in some sort of automation. In our CI/CD course, we talk a lot about this, where we're automating kind of command line tasks. And exit codes are super important. It's how we know whether or not our automation succeeded or failed. Also, it's very common that you'll have one program calling another program. For example, maybe a server, like a web server, has one program that automatically restarts the server if it goes down. So you have one program calling another program, and it will look at the exit code of the server program to see whether it crashed or failed gracefully, exited gracefully, and know whether or not it needs to restart it and what logic it needs to use to restart it. So exit code is very important. When we are in the shell, we can access the exit code of the last program using the ? Variable. So for example, if we just do ls, the home directory, and then echo the ? Variable, it's prefixed with a $sign because we're using a variable, we get 0. Now, if I ls something that doesn't exist, you'll see no such file or directory. This actually exited with a non-zero exit code. So if I echo ? Which again, ? is a variable that holds the exit code of the last thing I did, it's 1. Cool. Now, commands will usually exit with error codes if they've been run without the proper arguments or configuration. For example, our private bin warn.sh script will exit with a non-zero code if we don't provide the required environment variables. So let's go check out that script. So let's go to /private bin warn. Thought it was in here. Oh, I'm changing dirs. Yeah, there's warn. Okay. If you don't have the required environment variable set, so let's run it. Warn message is not set, exiting with error. Echo 69. What? Paste just the exit code of the text box to submit your answer. All right, 69. Let's submit that. So this is just to show that it doesn't need to be 0 or 1. Those are the common ones. 69, very odd. In fact, just really quickly, I want to show you cat warn.sh. You can see in the logic of the script right here, that's where it's exiting with the code 69. So whoever wrote this script literally just hard coded like, hey, when this happens, I want to exit with code 69. All right. Standard output. Now, you might not know it yet, but you're already a pro using standard output. We've been using standard output all throughout this course. We just haven't really talked about what it is yet. Standard output, also referred to as standard out or std out kind of in text when we're writing it, just to keep it short, is the default place where programs print their output. It's just a stream of data that when you're using a terminal emulator, prints to your terminal. It can be redirected to other places, but for now, when we're just using our terminal, it's simple to think about it as a stream of text that comes back from a program that we run and is printed to the terminal. All programming languages have a simple way to print standard out. It's like the most standard thing a programming language can do in terms of input output. In Python, it's just the print function, right? And again, in the shell, it's just echo hello world. That just prints hello world to standard out, which is why it shows up in our terminal. Assignment: use the grep command to print all the lines in World Bank Private Transactions 2020.csv that contain the word Marshall to standard out. All right, more grep practice. So let's go over there. Are we in World Bank? World Bank Private Transactions. All right, so we're gonna grep for the string Marshall. And we're gonna grep the file 2020.csv. There we go. It printed the lines to standard out. Copy the output and paste it in and submit. Now, standard error, usually called std_err, standard error, is a data stream just like standard output. So again, these are both just data streams. They're places where programs can write bytes to. The only difference is that by convention, it's where we send error messages, things like logs or problems. The reason it's a separate stream and programs don't just use standard out is so that the caller of the program can redirect the error messages and the success messages essentially to different places. Very often that you'll want to do that. Okay, so let's talk about actually redirecting the stream. So by default, standard out and standard error, when you are working in a terminal, you're running programs in your terminal, they will print standard out and standard error back to the terminal, both of them. So for all we know, if we didn't do any digging to check, this could be standard out or standard error. Now, we can redirect standard out and standard error to not go to the terminal, to not be rendered in the terminal, but instead to be written, say, to a file. You could also, you could redirect it anywhere if you're writing your own custom program, but like the easiest thing to do in the shell is to redirect it to a file. So, for example, echo hello world, as we know, by itself prints hello world back to the terminal, but we can redirect it to a file. So let me ls-l echo hello world hello.txt. Notice that it didn't print hello world to the terminal now. I ran echo hello world, but I redirected standard out to hello.txt. So I ls-l now, you'll see there's a new file here called hello.txt. Let's cat that. It has hello world inside because we redirected output there. This is very commonly used in backend development. You'll redirect logs to a file so that later you can look at your server logs. Okay, cool. I'm gonna go ahead and remove that. We don't need that. Now, redirecting standard error works the exact same way. The only difference is instead of just this, was that greater than sign? It's a 2 and then a greater than. That'll redirect standard error. Assignment: there is a process transactions.sh script in the World Bank private bin directory. Let's see, where are we? We're in World Bank private, so we'll go up a level. There we go. It accepts a path to a transactions CSV file as a positional argument, or CLI argument. Cool. So if I run, process World Bank private, I need to go to the bin. C bin ls. All right, there's process transactions. Okay, so it accepts the CSV file. It prints modern transactions after the year 2000 to standard out and old transactions before the year 2000 to standard error. Interesting. Run the script and pass it the path to 2020.csv. Okay, so we're gonna go / process transactions. Remember, we need the / because we're running a script in our current directory. Pass it in 2020.csv. Oh, which is in transactions. So / transactions 2020.csv. Okay. Redirect standard error to a temporary file. Okay. So to greater than /tmp/worldbank.log. /tmp is basically a special place in your file system for temporary files. If you need a temporary file, put it in there. There's certain logic that runs that assumes that those are temporary files. So it might get cleaned up later automatically. So you don't want to put like important stuff in there. But if it's think of it as like a kind of a scratch pad. And then I think we run it. Boom. All right. If you're missing 2020.csv, made a mistake in the previous step, we can ignore that. We don't make mistakes. Ensure the files in transactions match the files in transactions backups. If not, make a copy. Again, we don't need to worry about that. Okay, cat the file we just made. So if we ls-tmp, not ls, cat, let me clear so you can see this better. cat/tmp/worldbank.log. Boom. These should be the transactions that happened before the year 2000. As you can see, 1994, 1995, 1999. Awesome. Paste those transactions into the input. Boom. Standard in. All right, there's a standard output. There must be a standard input, right? That just makes sense. Standard input, usually called standard in or std in. It's the default place where programs read data. Now, it's important to understand that standard in is not the same as positional arguments. Positional arguments, they're just read once when you call the program. Same flags are arguments. It's not the same. Standard in is a stream that is read from as the program runs. Again, all major programming languages, for the most part, provide a simple way to read from standard in. And in Python, it's just the input function. So if you run this Python script, it says, what is your name? The program will actually stop and wait for the user to type something into their terminal. They will get a prompt, and that is then passed in through standard in. Cool. So the program basically blocks and reads from standard in until it gets a new line, which is what the enter key sends. Okay. Run the worldbank private bin worldbank.sh program again. Okay. Is it in here? Bin world. Nope. I forgot the dot. Worldbank. Welcome to your Worldbank CLI tool. Please enter your name. Take a closer look at the code. Oh, wait. Oh, I need to read the thing. Run the program again. Notice that it makes use of standard in to read your name and email. Okay. So please enter your name. The script is now waiting for input from standard in. Specifically, it's waiting for a new line. So it's going to capture what I type, lane in this case, and then when I hit enter, I send a new line through standard in. The program reads that and goes, I got the end of the input. Cool. Keep going. Keeps executing the program until it prints out, please enter your email. Now it's going to wait again. It's waiting for more standard in. Put my email in, lane@gmail.com. Finishes the program now. Name is Lane, your email is this. Cool. Take a closer look at the code, all right? Let's cat worldbank.sh. What command does it use to read from standard in? So let's just read this script. So the first thing it does is print to the console, welcome to the Worldbank CLI tool. Then it prints, please enter your name. Then it uses the read command, read name. So this in our shell language is saying stop and read from standard in, right? And wait till you get a new line and save that variable, or save that data, that string, into the name variable. And it does the same thing with the email. So it's that read command there. Copy the command's name into the input field and submit your answer. Cool, it's read. Piping. One of the most beautiful things about the shell is that you can pipe the output of one program into the input of another program. With this one simple concept, you can run powerful automation tasks. The pipe operator is how we do that. It's this character that looks like a vertical line. You're probably not used to typing the pipe operator. It's probably right above your enter key. It's like the shifted version of the slash. It's right above your enter key. The pipe operator takes the standard out of the program on the left and pipes it through into standard in of the program on the right. So, for example, we know that word count can be given a file to count words, but like most Unix-like tools, it can read from standard in as well. So, for example, echo my name is Lane, rather than allowing that standard out to go to the terminal, which is what it does by default, or redirecting it to a file, we're not going to do that. We're going to pipe it instead to the word count program. You can see this is, oh, I think I misspoke earlier. So this is lines, this is words, and this is characters, which we'll typically map to bytes, assuming ASCII characters. Okay, so echo, my name is Lane, word count, yeah, we got all of that. Assignment. We need to figure out how many transactions Bob has been involved with. Bob's looking sus. Use the grep command to find all lines in all of the transactions that include the word Bob. All right. So we need to grep for the string Bob. It says all the transactions. So we need to do recursive, which is a capital R. Path to the transactions directory, which is .. transactions. Yep. And then we need to excluder. We'll actually need to use a relative path here as well. .. transactions. I spell that right? Backups. Did I do that right? Oh, and then pipe the output of that command. Well, let's see if that works, first of all. It did something. Maybe it worked. I see Bob's in there. That's good. Do I see multiple files? I see a lot of 2022. Question is there any backup? I think we're good. We'll just send it. All right. Let's pipe that into WC-L. Let's count the number of lines. All right, we got 3,973. Let's see if we did it right. I'm not super confident. I kind of sped through that. And we got it. Interrupt. Sometimes a program will get stuck and you want to stop it. Common reasons for this are you made a typo in the command, it's not doing what you want. It's trying to access the internet, but you're not connected to the internet. It's processing too much data, and you don't want to wait for it to finish. There's all sorts of reasons that you're going to want to kill or stop a command that's not responding. If you've ever used Windows Task Manager, you understand. Programs, they hang, they freeze. Sometimes you just got to kill it, right? Okay, so in those cases where the program is hung, you can stop the program by pressing Control-C. What this does under the hood is it sends a SIGINT, signal interrupt, to the program, which is supposed to listen to that signal and stop. Now, we'll talk about later how that sometimes doesn't work, but it usually works. So inside the World Bank private bin directory, there's a program called malicious.sh. Do we see it? There it is. Clear, malicious-l, malicious.sh, there it is. As a good security auditor and knowing that you are on a secure system with no internet access, you want to see what this program does. Go ahead and run it. All right. It's doing scary. Oh, it's doing scary things. And if I press enter, it just keeps doing it, right? If I wasn't good with a terminal, I'd think I'm stuck. But we can run Control-C. Program exits, and you'll notice it actually printed a special thing here. That's because it was waiting for SIGINT. And when it received SIGINT, the logic of this script says, when I receive SIGINT, print malicious skullduggery complete and exit. Okay, paste the last line of its output into the text box. So we'll just grab this and paste it in. Cool. Kill. Okay, remember how I said sometimes programs don't exit? That's what kill is for. Sometimes the program is in such a bad state that it doesn't respond to SIGINT, in which case the best option is to use another shell session or a new terminal window to manually kill the program. All right, so let's go over this. So the kill command takes a PID as its first positional argument. PID stands for process ID, which is the ID given to it by the operating system so that, it's an ID given to it by the processing system or by the operating system. And we're going to need to use that so that the kill command knows which process to kill. Cool. How do you find the process ID? You use the PS command with the AUX options, which just means show all the processes, including those owned by other users, and show extra information about each process. Usually when you're looking for usually when you're looking for a program to kill, you want to use these three flags, or these three arguments. Again, this is very similar to like if you've ever used Windows Task Manager, or what's it called on Mac? Do I have it written down on here somewhere? In Mac, I can't even remember. That's embarrassing. I don't know. There's something. The one that lets you kill the programs. It's Task Manager on Windows. I don't know. I'm always having to kill games because they freeze. So anyways, let's jump into using it. So you did some digging and found out that the malicious program actually has another mode, force. Run the program again in force mode. Okay. malicious.sh force. SIGINT ignored due to force argument. Very scary. Try to kill the program with Control-C. It's not working. The script is just printing, haha, you can't stop me. This is a true virus. All right, copy the line that was printed to your terminal when trying to kill it and paste it into the field, but do not submit yet. All right. Open a second terminal window. Okay. And pipe the output of psaux into grep malicious.sh. So psaux, let me just show you what it looks like by default. So we get all this stuff. Like this is all the processes, right? So that's why we're going to want to use grep to find the one that we're looking for. So we grep or pipe this into grep. And we're going to grep for malicious.sh. And of course, we don't need to pass in a file name because the thing we're grepping is the input that's being piped from psaux. Grep for that. Cool. There are two things here. In fact, let me resize a little bit so you can see it become more clear. There we go. These two programs, like it says here, you'll probably get two results. One is for the malicious program itself, and one is for the grep command. So we don't want the one that we use. We don't want the grep one. We want the actual command we ran. So bash./malicious.sh is the one that we want, not grep malicious.sh. Okay, once you have the PID, process ID, that would be this number. Right? Yeah. Once you have the process ID, kill it. So grab that, kill. Wait. Is it this one? Wait. Is it this one? Ah! It is running, right? Yeah, there it is. Doing scary stuff. What am I doing? Where is the PID? What? Okay, it's not that first one because it's changing. But the second one's changing too. What? All right, I'm confused for long enough that we're definitely gonna have to cut this out. Whoever's editing this. Hey, what? Psaux, you probably get too. I'm stupid. I'm grabbing the top one. Oh my gosh. All right, cut back to this. Cut back to me being stupid. I'm being dumb. We want bash./malicious.sh. That's the one that ran the program. We don't want grep. Why am I grabbing the wrong one? All right. Here we go. Kill that one. Now, if we come back over here, it's dead. Wonderful. Once you've killed the program, you should see your original terminal window. That's this one. Return to a new prompt. And we did. Because it stopped running the malicious program. And just for good measure, let's do our psaux again. We can see it's no longer there. We still have the grep one. That's because that's the command we ran here. But that's not the one. All right, cool. With control of your terminal restored, submit the message the malicious program printed in step 2. Cool. Unix philosophy. All right. Unix philosophy is pretty cool. It's been around for a long time. And it's basically a simple set of principles that have guided the developments of Unix-like operating systems like Mac and Linux. And it can be summarized, I'm paraphrasing a little bit, to write programs that do one thing and do it well. Sorry, I'm going to have to cut for a second here. Kick my daughter out. It can be summarized, paraphrased, as write programs that do one thing and do it well. So, for example, fully fledged video games, not really Unix philosophy. Video games do all sorts of things. They're full-blown applications. They have GUIs, they have interactions, they have sounds, all that kind of stuff. That doesn't mean that like games are bad, but when we're talking about the Unix philosophy, we're talking about writing small composable programs. Things like grep. What does it do? It searches text for substrings. And it's very composable. You can use it to search files. You can also use standard out and piping to compose it with other programs. So that's kind of the whole thing with the Unix philosophy. Small, simple programs. You want them to be able to work together using the text interface, piping, right? Input, output streams. And the idea is that's a universal interface. So the whole idea is we build all these different programs that use text and handle standard in and standard out, and then we can pipe them all together to build really sophisticated automations. This is why IT ops, DevOps people, cloud engineers, they're able to get a lot done just with the command line because they can compose all of these interesting automations using pre-existing programs. They don't always need to write custom software for everything they want to do. Cool. All right. Questions. On to the questions. Which of the following does not follow the Unix philosophy? Cat grep ls World of Warcraft.exe. That's the only one. Which is the more powerful interface, at least from an extensibility and interoperability standpoint? Text or graphical? It's going to be text. Top. Cool. The top command is a very powerful tool. It allows you to see which programs are using the most resources on your computer. This was the lesson. It's activity monitor. That's what it's activity monitor. I never use it on Mac. That's why I don't remember. But yeah, task manager on Windows, activity monitor on Mac OS. They let you see all the programs that are running. You can kill them from that GUI window. So looking at them and killing them, that's what psaux and kill are great for. Top is similar, but rather than using it to kill programs, I typically use it to look at resource usage. So I want to see how much CPU, what percentage of CPU programs are using, how much memory or RAM they're using, that sort of thing. So let's go ahead and run top. Like less, nano, whatever, it is an interactive CLI command. So you'll notice my prompt is gone. I've got to hit Q to get out of top. But it basically sits here and tells me, what is running on my computer that's taking resources. And I'm recording a video right now. And so OBS Studio is currently using 2.3 CPU cores and dwarfing the resource usage of everything else. So this is pretty cool, right? Just by running top, you can kind of see, hey, what programs are hogging all of the resources on my machine. Copy the column names from your terminal. So the column names are up here. So you can see we actually do get a PID here, process ID, in the top command. So we could have found the PID for the kill command this way. I wouldn't probably have used top to do what we did in the last step because that script, malicious.sh, it wasn't using very many resources. It was just very slowly printing text to the terminal. So it wouldn't have shown on top in the top command because it's not using a lot of CPU. And the top command kind of sorts by resource usage by default. So psaux made a lot of sense. If you are trying to kill things that are using too many resources, top's great, and you can just grab the PID from here. Cool. So copy the column names, got it. And then exit top with Q and paste it in. Good to go. All right, last chapter, package managers. A package manager is just another piece of software that manages other pieces of software, right? So you've got all these programs on your computer. I mean, we took a look at bin. If I just ls/bin, see all this stuff in here. These tools, it was a bad example. They came bundled, they came installed, but other tools that you might want to install that don't come on your machine are typically installed with a package manager. On Linux, well, I should be specific, on Ubuntu, kind of the default package manager is apt. So if you've ever sudo apt get installed, that's what Ubuntu uses. And then on Mac, there isn't an official package manager, but kind of the unofficial one that everyone seems to use is Homebrew. So brew install. All right, cool. So let's install something using a package manager. That's the assignment here. NeoVim is a hyper-extensible and newer version of Vim, which is a new version of VI, which is a popular text editor. So we were using Nano earlier in this course. It's good to know about Nano just because Nano is like always there. Basically any system you log into will have Nano available. It's very, very lightweight. It's also not nearly as powerful as something like NeoVim. NeoVim is a much newer, much more powerful CLI text editor. So let's go ahead and install it. We're not on WSL Ubuntu. So if you're on WSL Ubuntu, you can install, follow these instructions. We're going to follow the Mac instructions. I'm gonna brew install NeoVim, which I actually think I might already have NeoVim. About to find out. So this is gonna go ahead and install. Okay, looks like the installation finished. Now we're gonna test that. Oops, clear. By running nvim neovim -- version. And we got version 0.10.3. Perfect. We'll paste that output into the text box. Very good. All right, using NeoVim. This isn't a course on NeoVim. We'd need a lot more time for that, but I'm at least gonna show you how to enter and exit NeoVim, because it's likely that you'll find yourself in Vim at some point and wondering how to get out. So let's go ahead and use NeoVim to open up World Bank public company info. So // where are we? World Bank. So nvim public company info. All right, now we're in NeoVim. We're looking at the contents of that file. It's a text file that uses Markdown syntax. Great. You can open a file. We already did that. Once it's open, we notice that we can't type anything. This is very important. If I type J, K, what? It's like moving me around. This is why people get really confused in Vim. Typing letters, but they're not typing. My cursor is just moving. In order to type, we actually have to exit the mode that we're currently in, which is called normal mode, and go into insert mode. We do that by pressing the I key. So let's do that. And now here at the bottom, we can see insert. That means we're in insert mode. So now if I type, I'm editing the file. All right, you should now be able to delete the password. So let me go back into normal mode and move over to, where am I deleting? Some password. Oh, I'm just deleting the whole password. Okay, so I'm gonna go into insert mode, delete the password, type in redacted. Now we're gonna exit normal mode with the escape key. You can tell because now we've got the full character highlight instead of the flashing bar. We're back in normal mode. In normal mode, we can use the :W command. So if you look down here at the bottom, you'll see I type colon, then I type W, hit enter, that saves my changes, and then :Q. So earlier in the course, you'll remember me saying that just pressing Q doesn't exit NeoVim. That is true because you need to type :Q while in normal mode. All right, that gets us out of NeoVim. We've escaped NeoVim. It's a huge badge of honor. Use cat to view the contents of the edited file. Public company info. And you can see it's now changed. Great. Let's paste that edited file in here. All right, package manager review. So apt and brew are not the only package managers out there. I don't want you to get that impression. They are just some of the more popular ones, especially for Ubuntu and Mac. When you type a command like apt install NeoVim on Ubuntu, the package manager does a few things. First, checks to see if the package is already installed. If it's not installed, it goes and downloads the package from the repository. So apt has its own repositories of kind of the published versions of these softwares, and it will go download that if it doesn't have it. Then it will install it on your computer, which basically means it puts the program somewhere on your file system. It will also install any dependencies that that program needs in order to function. This is like the really hard thing that package managers do. It's not trivial to figure out all those dependency trees and make sure that they're all up to date and working. And then it will also hopefully automatically add that program, that binary, if it is a binary, it might be an interpreted program, whatever, to your path if it should be there. That way you don't need to go manually muck with your path. And again, this is important to understand. Usually a brew install or an apt install will just add an installed command like neovim, right? Nvim was added to our path, so we can use it from anywhere. Can I exit neovim? There we go. But if it didn't, we need to go find it and add it to our path. So if we want to see where it is, I can do which neovim. You can see opt homebrew bin neovim. So opt homebrew bin, this is of course in my path. And brew put it there for me, I believe. Cool, what do you know? It's gonna ask us to do which nvim. Question, what do package managers like apt and brew not do? Manage the installation of software and its dependencies, they do that. Download software from the internet, they do that. Debug code and fix bugs in the software it manages, no, they're not debuggers. Webby. There's one more package manager. It's actually more of an anti-package manager that I want to show you. I think it's a really cool project. Webby lets you install command line tools directly from the web with no need for a local command line tool like apt or brew. So apt and brew are very kind of sophisticated. They've been around for a long time. But the point is you need apt or you need brew on your system. When you buy a new MacBook, it doesn't come with brew. You have to go download and install brew itself. And then you use brew to manage a lot of your tools. The really cool thing about Webby, in my opinion, is that it has no package manager. It's basically a web server that serves up the official installation scripts for various popular tools. It allows you to install tools via their official installation instructions, but like all from one interface. So let's go ahead and use it, see how it works. We're going to install LSD, which is a more modern version of the ls command written in Rust, I believe. So first we're going to go to Webby, and let me zoom in here. And we're going to find the LSD program. Search for it. There it is. LS Deluxe. Cool. And then we're just going to install it using installation instructions. So this is basically how Webby works. It's pretty awesome. Select your operating system. Usually it's the same command, but of course Windows has to be special. We're just going to grab this. Now keep in mind, I haven't installed Webby on my machine. I'm just grabbing this curl command and running it in my terminal. We're going to talk about the security implications of that in just a second. But for now, I'm just going to do it. Run that. And it installed LSD. It shows me where it put it. It put it in my home directory under local bin LSD. And I believe it has added it to my path automatically. Does it say that? Well, let's find out. LSD. I've got it. Okay, cool. We're good to go. So it did it automatically. If it didn't do it, we'd have to add, of course, .local bin to my path. Okay, back to the lesson. Try running LSD with the -- tree flag. Clear LSD -- tree. Oops. LSD. I'm not LDS anymore. Got to spell that right. Cool. That's awesome. I love that. Builds out that whole file tree for us. Cool. Run it again with both the tree and classic flags. All right. That gets rid of color, it looks like. Cool. Paste the output into the field. Oh, I need to do the right place. World Bank private transactions. All right. So LSD, we want private transactions -- classic -- tree. Very good. Grab that one. Pop that bad boy in. Now, before we move on, like I said, I want to talk about security for just a second. So one of the maintainers of Webby, his name's AJ. He's awesome. He actually came on the Backend Banter podcast to talk about Webby. A lot of people, very reasonably so, get nervous when you have to paste a command like this one, into your terminal and run it. So why? Why are they nervous? What is this? Well, this is a curl command that basically says, hey, go to this remote server, webby.sh, download the script, and immediately pipe it in. See, we're piping the script itself that we're downloading into my shell interpreter. In other words, download this thing from the remote host and execute it immediately. right? That's basically what this is. That's exactly what this is doing. There's some security concerns there, right? What if this web server gives me a malicious script, right? What if it's a malicious script that screws up my machine or looks for credit card numbers or anything like that, right? So the typical advice, of course, is, well, you should download the script first, look at it, inspect it, make sure it's safe, and only then run it. You should only use, that's assuming you're able to look through the script yourself. In the case of like actual programs, you typically want it signed by the publisher of the script to make sure that it hasn't been tampered with or changed. Okay, all that to say, if you're really curious about AJ's argument for why this isn't really a concern, I would definitely recommend checking out the podcast because he'll do a much better job of explaining it than I will here, but I will give you the gist. So the first thing is we're using HTTPS, which guarantees a couple things. First of all, it guarantees, because this is just how HTTPS works, that the script we're getting was actually securely signed via HTTPS, that cryptography, by the owner of the webby.sh domain name. So do we have to trust Webby? Yes. When we run this, we are putting our full faith and trust in Webby to not screw us over. So yes, if Webby got hacked, someone could change the server to serve up malicious scripts. That is a security risk, and it's important to understand that. If you are nervous about that, of course, you could always just curl the script first, then read it, then execute it. There's no reason you can't do that. But it is important to understand you have to trust the source. But because we are using HTTPS here, we're really not concerned about a man-in-the-middle attack, right? Someone getting in between us and the Webby server and altering the script, just because that's the whole point of HTTPS, right? HTTP, the script's guaranteed to show up in order so we can execute it. HTTPS, it's guaranteed to be coming from Webby. It's been cryptographically signed. It's about as good as it gets. So are there potential security concerns with Webby? I think they are, but I am on AJ's side after the conversation we had, in the sense that I do think they're minimal. And I think that, there's a risk to everything you do online. So anyways, use it at your own risk, I suppose. I do think it's a really cool tool, and just to be aware of that it's there. And like I said, go listen to that podcast if you're interested. Cool. Done with Webby. VS Code. Now, up to this point in boot dev, you've written code. If you've been following along on boot dev, so if you've done our Python course and now our Linux course, you've probably written all your Python code in the browser, in boot dev's in browser editor. And then now we've been using a standalone terminal to do this course. Some developers do their work inside a terminal using a terminal editor like NeoVim. I actually don't. I'm not that cool. So a lot of us that, I can say we're not cool because I'm in this group, but a lot of us do use a hybrid kind of GUI/terminal experience. I used to use VS Code. It was my daily driver for many years. I have recently, just in the last year, switched over to another editor called Zed that I really like. Big downside to Zed at the moment is it doesn't work well with it doesn't work at all on Windows. And so if you're doing like a Windows WSL thing, Zed does not have a good experience, or I don't even think it works at all. Whereas Visual Studio Code is built out of the box to work with WSL, which is pretty awesome. So if you're on WSL and you're new to all this stuff, like VS Code genuinely is a really good option. If you are interested in getting really good at Vim, which is like a whole skill set in and of itself, then definitely check out NeoVim or Vim. And you'll also hear Emacs thrown around. I have nothing to say about Emacs. So if you don't have a preferred editor yet, I would just recommend installing VS Code if you're on Windows, and honestly checking out Zed if you're on Mac or a straight Linux installation. And with that, I hope you've enjoyed this course. I hope you've gotten a little bit out of it. Like I said, this is not a course on the entirety of Linux as an operating system, as a kernel, I should say. This is a course on how to get up and running with a Unix-like command line, and most people associate that with Linux. A lot of people develop on Mac or on Windows and deploy to Linux servers. So it's really, really good to know how to SSH into a server, which basically means connects to a server via terminal, and muck around with it, use it, run programs, see what's going on, look at logs. All that kind of stuff is what we learned in this course. You'll use it not just for server management, you'll use it on your local machine as you're installing tools, doing local development work. Thanks so much for staying with me this long.